The first space shuttle to fly was dubbed Enterprise. This was only after the American public, and in particular the science fiction fan element, pressured NASA to name it after a popular TV franchise's spacecraft. Unfortunately, Enterprise was purely an atmospheric test vehicle and never destined for orbit. The Space Transport System, STS for short, or more commonly known as the Space Shuttle, was to be a great leap forward in space transportation. It was a reusable launch vehicle that could carry large payloads to orbit, then return to Earth as an unpowered glider, where it would be quickly turned around and readied for another flight. Reusability to reduce costs. The shuttle would become the most advanced and complex machine ever built. It would be a two-stage vehicle, the shuttle with three main engines fed from a large external tank, which had strapped to it two solid reusable rocket boosters.
This animation shows how they work during launch. The two solid rocket boosters strapped to each side carry their own propellants and burn for about 2 minutes before separating. Their onboard parachutes will then bring them back to Earth for recovery and reuse. The large external fuel tank continues feeding the shuttle engines for an additional 6 minutes, separating just before the shuttle reaches orbit. This is the only part of the shuttle system that will not be used again.
Once achieving a low Earth orbit, the cargo bay doors would swing open to access its cargo and dissipate unwanted heat from the launch. Unlike any of its predecessors, the shuttle dwarfs the conventional capsule and would provide room for a crew of up to 8 astronauts and specialists on 2 decks, with additional workspace available when flown with Spacelab in the cargo bay. The shuttle stack is a little under half the height of the venerable Saturn V moon rocket, but would utilize all the facilities, including the vertical assembly building and launch crawler. The first spaceflight-capable shuttle was Columbia, or OV-102. As large as a commercial aircraft, the Columbia was 37 meters long, with a wingspan of 24 meters, and its large vertical stabilizer making it 17 meters tall and weighing 75,000 kilograms when empty. The shuttle's payload bay, at 18 meters long, could carry up to 29,500 kilograms of payload. A vehicle of this type required new technologies and new materials to be developed. A case in point, the thermal tiles that cover the orbiter and protect it on re-entry into the Earth's atmosphere. This high-temperature, reusable surface insulation was made of 97% pure silica sand, and each tile was unique in size and shape, and all were attached by hand. These tiles could withstand temperatures up to 650 degrees Celsius. The nose cone and leading edges of the wings, where the highest temperatures on re-entry would be achieved, were made of reinforced carbon-carbon and could withstand 1650 degrees. The white upper sections of Columbia were designed to withstand 370 degrees. The main engines of the orbiter were also the pinnacle of rocket motor technology. Burning liquid hydrogen and liquid oxygen, it can produce a rated thrust of 1.7 million newtons, and thrust is variable from 65 to 109% of this rated value. The supercool hydrogen fuel is pumped around the engine nozzles to keep them cool before entering turbo pumps that are also driven by propellant pressure, making them very efficient engines. Each launch of the shuttle will only require 8 minutes of main engine burn. Designed to last for 7.5 hours, each engine should see out 55 missions. In that 8 minutes, the 3 engines will consume 540,000 litres of liquid oxygen and 1.5 million litres of liquid hydrogen, all fed from the 47-meter-long external tank. Originally painted white, NASA quickly realized a weight saving of 455 kilograms could be made if it wasn't painted, leaving the orange-brown urethane insulation exposed. The third and final component of the shuttle system is the 2 external solid rocket boosters. Each 45.5 meters tall and capable of 11.8 million newtons thrust, they were required to help lift the shuttle stack in the initial stages of launch. These were assembled from sections and fitted with parachutes so they could be recovered and refurbished. The largest solid fuel rocket ever flown, they burn for just 2 minutes and then are jettisoned from the main tank. With aerodynamic and landing tests complete, there was now only one test left to perform: a launch. Assembled and fueled, the shuttle Columbia sat on the floodlit pad April 12, 1981. This was the first time in NASA's history that they would perform a test launch of a new vehicle system with pilots on board. And they were pilot Robert Crippen and seasoned veteran astronaut John Young commanding. Young held several distinctions, including having walked on the moon, piloted 4 different types of space vehicle, and being the first man to make his 6th flight into space. Both astronauts were aware of the additional hazards of this flight. There was no traditional launch escape system as on previous manned flights. This first shuttle flight was fitted with ejection seats, their effectiveness at such speeds and altitude a gamble. Secured aboard their craft, ground computers armed with the most complex programming ever written began the final countdown. The 3 shuttle main engines ignited, the entire stack twanging back and forth, held down by explosive bolts. Then the solid boosters ignited, the spacecraft slowly rising from the launch pad. After being grounded for 6 years, America was returning to space.
Roger, roll. Roll program complete. Roger, roll complete.
The shuttle performed exactly as had been predicted by computer simulation and hoped for. Achieving low Earth orbit of 307 kilometers, the first priority was opening the cargo bay doors. Attached to them were radiators that would help cool the craft from the heat it had gained in the launch process. Young and Crippen then set about testing the complex systems and controls. In orbit, the shuttle can maneuver and deorbit with the use of the OMS engines, 2 smaller motors clustered with the main engines. It also has numbers of maneuvering thrusters. It was on these OMS pods that it was discovered several thermal tiles had come loose and been lost. As they were not critical thermal areas, it was deemed not a serious threat to the craft on re-entry. STS-1 remained in orbit for only 2 days and 6 hours, then began the critical test of re-entry and landing. Edwards Air Force Base, where previous landing tests had taken place, was the chosen site for the first operational landing.
3, touchdown. Houston, Columbia's on the roll. Welcome home, Columbia. Beautiful, beautiful.
After close inspection of the orbiter, it was found that many thermal tiles had either been damaged or lost completely. 2 tiles on the critical lower surface were damaged enough to allow hot gases to enter the vehicle's interior structure, causing severe buckling of one of the landing struts. Also noticed were the computer errors in predicting the control performance of the orbiter at high speeds in the atmosphere. These issues were quickly corrected for the next launch. The shuttle was returned to Cape Kennedy via 747, and the refurbishment begun. In November the same year, Columbia lifted off for the 2nd time. The first time a spacecraft had been in orbit, then returned for a 2nd time. Then again, and again. In all, there were 4 shakedown missions performed by Columbia, each launch proving the capability of this flying machine. One of the components tested during these flights was the Canadian-built Shuttle Remote Manipulator System, which lay along one side of the cargo bay. Also called the Canadarm, it is 15.2 meters long and 38 centimeters in diameter and weighs 410 kilograms. Divided into main sections, they are called the upper and lower arm. It has 6 joints, giving it the same flexibility as a human arm. It is connected to the shuttle by the shoulder connector, and the other end connected to the wrist is the end effector that can grab payloads by specially designed capture points.
Some general comments on the arm operation. The operation is smooth. There's definitely a little bit of flex and dynamics, but in the augmented mode, that's very minimized. Really no surprises. If there are any surprises, they're all pleasant. I'm really impressed with that piece of machinery.
The arm carries several cameras to enable the operator to see all the joints and their locations at all times. This also gave the astronauts the ability to inspect other parts of the orbiter not seen from a porthole. STS-5 carried 4 astronauts into space, where they performed the first 2 satellite deliveries. Bound for geosynchronous orbits, the shuttle deployed the communications satellite with a PAM booster, or payload assist module, attached. They were spun up to a stable speed and spring-ejected from the payload bay. At a safe distance from the shuttle, the PAM rockets would fire, placing the satellite into the correct orbit. STS-5 was also the first flight of the shuttle where the crew did not wear pressure suits in the launch or landing phases. This procedure was the same for Soyuz until Soyuz 11, when 3 cosmonauts perished from a rapid pressure leak. By April 1983, it was the turn of the second orbiter in the fleet to be flown. Because the Challenger's airframe had been built as a test for shuttle construction and completed sometime before Columbia, it was identified as Orbiter OV-099. The frame manufacture was so good, NASA decided to save money and use it as the basis for the next orbiter. It had several modifications in design from Columbia, with fewer thermal tiles and more use of the Nomex felt insulation. It also introduced head-up displays in the landing phase, and the cargo bay was modified to carry a Centaur G upper stage for future missions. There were to be 4 spaceworthy shuttles in total. Discovery and Atlantis were still to be fitted out. 4 shuttles would be the ideal number to maintain a regular flight to low Earth orbit. Challenger and flight STS-6 would again carry a crew of 4 and the first of the TDRS satellites. These $100 million communications and tracking satellites would become the primary communications channel between NASA and space vehicles in orbit. The massive satellite was elevated up and eventually jettisoned from the cargo bay. Attached to the satellite was a PAM unit which would raise the satellite to a geosynchronous orbit. There it would be deployed, extending solar panels and large antennae. The system would require a total of 9 TDRS satellites, with 3 satellites as the main element. Each would have 2 replacements if required. The system will allow extended communications with orbiting spacecraft and an increase in data exchange. The ground elements of the tracking network included Goddard Space Flight Center, White Sands Complex in New Mexico, and a station in Guam. This network will also allow communications with ground bases in remote areas like Antarctica to be linked with a high-speed data and communications capability. Other orbiting facilities would go on to use this satellite network. Soon-to-be-launched Space Telescope Hubble would use it, as well as Landsat satellites. Primarily financed by the Pentagon, the TDRS system also carries extensive military and classified traffic. Challenger quickly became the workhorse of the shuttle fleet. For the next 2 years, Challenger would fly 85% of shuttle missions. STS-6 would also be host to the first tethered spacewalk for a shuttle mission. The 2 mission specialists, Don Peterson and Story Musgrove, donned the newly designed off-the-rack spacesuits and maneuvered themselves out through the cargo bay airlock. Remaining tethered to the spacecraft, the 2 men performed numerous tests, encompassing the length of the cargo bay. The EVA of over 4 hours was the first for the Americans since Skylab. The newly designed EMU suits for the shuttle were the result of years of research into suit design. They consist of a rigid upper torso, which includes the arms, gloves, bubble helmet, and primary life support system, including electrical power. The lower, separate section is the lower torso assembly, a soft, flexible brief, legs, and boots. This includes the waist bearing, which seals the body. A liquid cooling and thermal ventilation garment is worn underneath, containing clear plastic tubing which circulates chilled water, and gas ventilation tubing. STS-7 was Challenger's second flight, and it carried a crew of 5, including the first American woman into space, Sally Ride, a mission specialist. The flight delivered 2 more satellites to orbit. They also deployed and then later recaptured the SPAS experiment package using the remote manipulator arm. The next flight was STS-8, and Challenger was the first night launch of the shuttle. It also took aloft the first African-American mission specialist, astronaut Guion Bluford. STS-8 deployed an Indian communications satellite and, in a money-making venture, carried 261,000 franked covers or stamps to be sold on their return for a profit. A scheme that years earlier had gotten 3 Apollo astronauts into hot water. Guess you can't keep a good idea down. The 11th shuttle mission, and Challenger's 5th, was the most daring yet. The major task was something never attempted before: the capture of a satellite in orbit, repairing it in the cargo bay, and setting it free again. The Solar Max satellite had been launched earlier in February 1980. It was to study the sun, in particular solar flares. A malfunction cut short its mission after only 11 months. They used the remote arm to snag the satellite and pull it into the cargo bay, where it sat on a special cradle. Then the astronauts went to work, replacing the faulty attitude control mechanism and the main electronics. One astronaut was strapped to the remote arm to better access parts of the satellite, although he didn't quite like it.
Really an uncomfortable feeling. Do you feel like you're going to fall? I feel like I'm going to fall.
Once repaired and checked out by ground control, the satellite was released back into orbit. Solar Max resumed its work studying the sun and went on working for another 5 years before plummeting back to Earth in December 1989. The mission was captured on an IMAX camera flown aboard the shuttle, and the film would eventually be released in 1985 as The Dream is Alive.
Procedures on the ground are being streamlined for the operational era. Processing time was cut in half during the orbital flight test program. Presently, it takes approximately 13 weeks to prepare the space transportation system for launch. It is projected that by the mid-80s, there will be 2 shuttle launches per month.
And so the shuttle flights became more regular, achieving more each time with larger crews. The European Space Lab 1 flew, including experimental packages studying life sciences, plasma physics, astronomy, high-energy astrophysics, solar physics, atmospheric physics, and technology research. Numerous satellites were deployed, and scientific instrument packages placed in orbit, then retrieved by later shuttle missions. Discovery, the 3rd shuttle orbiter, flew its first mission on 30th August 1984. She would go on to fly the most missions of all the shuttles and was the first to dock with the Soviet Mir space station. With each confidence-building flight, more were being planned, more goals achieved. Construction techniques studied in the vacuum of space for the upcoming International Space Station assembly. Atlantis, the fourth orbiter, was launched October 1985. The most advanced of all the shuttles, she incorporated all that had been learned from the earlier designs. By the 24th shuttle mission, over 118 astronauts and specialists had flown into space. Dozens of communications and specialist satellites had been launched. The first female spacewalk occurred during the 13th flight. Columbia had flown 7 missions, Challenger 9, Discovery 6, and Atlantis 2.
We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Within the blink of an eye, the 25th mission milestone had been reached. The STS had proven itself as an outstanding launch vehicle, capable of lifting satellites into orbit, retrieving errant ones, and repairing them in situ, saving millions of dollars. Carrying crews of up to 8 astronauts at a time and conducting extensive scientific research in orbit, the massive costs of development of the shuttle were paying off. With the proven flexibility to remain in orbit if weather conditions for landing were hazardous, or even selecting different landing locations, it was a shining beacon of American engineering and ingenuity.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
The Space Shuttle Challenger lifted off from Cape Kennedy January 28, 1986. It was the 25th shuttle flight and the 10th for Challenger.
Throttling up, 3 engines now at 104%.
Challenger, go with throttle up. Challenger, go with throttle up.
The destruction of the orbiter 73 seconds into its flight was a devastating blow for NASA, the crew's families, and the American people. It was the worst single U.S. spaceflight accident and the most lethal since the Apollo 1 fire. Broadcast live around the world, the crew's families were there to witness the launch, and cameras caught their expressions as they turned from fear and exhilaration to confusion, then shock and horror. On board, a full crew of 7 astronauts. One in particular was of great public interest. She was Krista McAuliffe, a school teacher. McAuliffe had been selected from 11,000 applicants for the Teacher in Space project.
Teacher in Space.
She was to become the first teacher in space and to have taught 2 classes from the shuttle whilst in orbit. Other crew on their first mission included Gregory Jarvis and pilot Michael Smith. For the other crew members, this was their second venture into space. Mission specialists Judith Resnick and Ellison Onizuka, Ronald McNair, and Commander Dick Scobie. The cargo bay of Challenger contained another $100 million TDRS satellite. Immediately after the accident, NASA went into lockdown mode, saving all the data and any other information available to help an investigation into the accident. Shortly after the destruction of the orbiter, the range safety officer sent out the signal to the remaining solid rocket boosters to self-destruct, as they were deemed a danger as they continued flying off in separate directions. The television broadcast showed pieces of the spacecraft splashing into the ocean some minutes later. There was no hope of rescue for the crew. The range safety officer also kept all rescue ships and aircraft out of the area for an hour, as debris continued to rain down and was an obvious danger. The investigating commission was as high-powered as possible and included former Secretary of State William Rogers, astronauts Neil Armstrong and Sally Ride, world-renowned physicist Richard Feynman, several aviation specialists, Air Force generals, and even veteran test pilot Chuck Yeager. This group of high-profile experts were more than capable of finding the truth, no matter how sensitive, and making strong, undiluted recommendations for the future of the shuttle program and indeed NASA. The investigation team went back to the beginning, the assembly of the shuttle components, the solid rocket boosters, and the external tank. They checked the procedures that were in place in the assembly of the shuttle stack. The launch of Challenger was rescheduled several times, resulting in the final countdown on January 28th. The weather was forecast to be clear and cold, with the temperatures dropping into the low 20 degrees Fahrenheit overnight. The fueling of the external tank began at 1:25 a.m. Ice had accumulated on the launch pad during the night. Several water systems were opened slightly and allowed to flow into drains. The drains froze and caused overflows. High wind gusts spread the water over large areas, and ice formed. The air temperature at launch was 36 degrees Fahrenheit, 15 degrees lower than any previous shuttle launch. The investigation team then looked at the launch video and photographs in great detail to look for any anomaly that might present itself. Sound suppression water began to flow. The accumulated hydrogen burn-off around the engines was commenced. The main engines went through their pre-programmed gimbals, then set to launch configuration. 6.6 seconds before launch, the main engines are ignited and run up to full power. This causes the shuttle stack to rock or sway out of alignment, then back again. The twang effect was incorporated into the launch sequence. When the shuttle stack returned to the vertical, the solid rocket boosters were ignited. At T0, explosive bolts release the solid rockets and the shuttle begins its ascent. Challenger cleared the tower, and the pre-programmed roll maneuver commenced 7 seconds after launch. The roll maneuver was completed after 21.124 seconds. Then the main shuttle engines were throttled back to 65% for about 16 seconds as the shuttle went through max Q, or maximum dynamic pressure. At an altitude of 9 miles and a speed of 2,900 feet per second, the external tank ruptured, then disintegrated. Contrary to common belief, the tank did not explode.
15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles.
Investigators then looked at 3 cameras positioned around the launch site. There, they discovered an anomaly. At 0.678 seconds after launch, a puff of grey smoke was spotted coming from the vicinity of the aft joint on the solid rocket booster. This revealed that there was not a complete seal at the joint of the solid rocket booster. The second camera angle confirmed the presence of this dark smoke emitting from the solid booster. The mechanical joint of the booster was leaking. The 2 images together show the growth of the dark plume as it moves upward from the seal, then downward as the shuttle rises, appearing on the left image, then a second later on the right image. A third angle, close up, revealed the plume in higher detail. It would seem that NASA had found its smoking gun.
As indicated on these pre-flight photos, the smoke emerged from just above the strut, between the SRB and ET, at a point along the longitudinal axis near the aft field joint.
As the commission members studied further recordings of the launch, the O-ring in the right rocket booster became their center of focus. The rubber in the O-rings failed to function correctly at lower temperatures. This failing could lead to hot gases from the rocket engine leaking out of the casing joint. Analysis of flight footage revealed the hot gases escaping from the O-ring joint, burning the side of the external tank and the final destruction of the spacecraft. Further analysis of the video showed the breakup of the orbiter, and in particular the crew cabin remaining intact as it fell out of the sky. To confirm their theory, investigators had to retrieve as much of the debris as possible. 22 ships, 6 underwater search vessels, and 33 aircraft participated in the search for the remains of the shuttle. The initial pieces recovered were floating on the surface of the water. The submarine fleet was used to locate debris by sonar, then make a visual identification of the piece. If relevant to the investigation, it was to be recovered. 50% of the entire vehicle was recovered in the effort. An area of over 93,000 square miles, up to depths of 370 meters or 1,200 feet, was combed. The recovered hardware was brought to the logistics facility, where reconstruction of the vehicle was undertaken. Experts analyzed the structural breakup of the orbiter and external tank to help prove the investigators' theory. Pieces were distributed on the floor of the facility, and eventually 45% of the orbiter was accounted for. It proved the orbiter itself and the payload did not contribute to the accident. It also proved that the orbiter broke up due to aerodynamic effects and not explosive effects as once thought. Shown here are parts of the forward fuselage that surrounded the crew cabin. Scorching and other thermal effects were seen on the right side of the rear parts of the orbiter, including the rudder and elevons, whereas the lower left side of the orbiter showed no heat stress or damage. No parts of the orbiter showed explosion or fire effects from within the vehicle. The external tank and solid rocket boosters were also recovered in pieces and reassembled as best as possible. The section of most interest at the rear of the external tank, where it meets the booster rocket, was recovered in one piece. It showed that the lower strut of the booster rocket had broken away. The external tank debris showed extreme stress to the inter-tank section, showing that the upper tank collapsed down as the lower hydrogen tank emptied into the air. The range safety explosives built into the tank had not detonated, proving the tank itself did not detonate. "50% of the solid rocket booster hardware was recovered and stored in an isolated ordnance storage facility, as some booster parts still had unburned propellant attached. The right solid booster's markings verified the course of events of the disaster. The very cold O-rings of the lower section of the booster rocket failed, permitting smoke and flame to exit the side of the booster. This in turn burnt the lower section of the external tank, causing it to fail. The lower strut of the booster broke away and allowed the rocket to twist away on the upper strut. Simultaneously, the cryogenic hydrogen propellant was dumped into the atmosphere. The external tank then crumpled under the dynamic pressure and fell apart. Some hydrogen fuel did burn. The shuttle itself then began to break up and plummet back to Earth. The astronauts did commence emergency procedures in the seconds following the breakup, but the high Gs would have quickly rendered them unconscious. The crew cabin hit the water with a stopping speed of 200 Gs, destroying the cabin and killing the crew outright. The results of the investigation also criticized NASA management and the contractor for the O-ring design, as the danger of such a weak design had been pointed out. NASA was also criticized for lack of communication and the decision-making judgments to launch. 9 recommendations were made by the Commission. The Commission concluded its report, and the shuttle fleet was grounded whilst the booster rockets were redesigned. It would be 3 years before another shuttle would fly.
7, 6, 5.
A new shuttle was commissioned to replace the Challenger.
1. Booster ignition.
Endeavour would roll off the production line and would fly May 7th, 1992.
Space for a larger international family.
The grounding of the shuttle fleet had future flight payloads retasked to more conventional rockets. The time-sensitive Giotto probe was to have flown the shuttle with an American probe, but cutbacks cancelled the additional probe. Giotto was destined to intercept Halley's Comet, the flyby scheduled for March 1986.
Ignition. Ariane, first stage ignition and takeoff. Takeoff and décollage.
Giotto was launched via the European Ariane rocket, 2nd July 1985. This was the European Space Agency's first deep space probe. Once in space, the probe was placed in a geostationary transfer orbit and spun up to 90 RPM, and then the apogee boost motor was fired, sending the probe on an intercept course with Halley. Halley's Comet spins around our Sun every 76 years, so the timing of the Giotto probe was crucial. It had many challenges to face, not least the dust particles moving at speeds 50 times that of a bullet. Giotto was designed to reach as close as 596 kilometers from the nucleus. The probe and comet approached each other at 245,000 kilometers per hour. At that speed, a dust particle could penetrate 8 centimeters of aluminium. Success was achieved March 13, 1986, as the probe passed by Halley, taking photographs and scientific observations. Giotto found the nucleus of Halley to be blacker than coal, and it ejected about 3 tons of matter per second. This ejecta consisted of 80% water, 10% carbon monoxide, 2.5% methane, and ammonia and traces of iron, sodium, and hydrocarbons. The probe was hit by dust particles and knocked off its axis. Some sensors and cameras were also damaged by Halley's cloud of particles. The probe corrected its orientation and continued to function for the rest of the encounter. It then went on to a second rendezvous with the Grigg-Skjellerup comet many years later. The Soviets, accustomed to their own spaceflight disasters, carried on. Their next project was Mir. Mir is Russian for either peace or world, and was a direct development out of the Salyut space station program. In fact, the construction of Mir began before Salyut 7 had been abandoned. Mir was constructed over a period of 10 years and inhabited for nearly the entire time. Mir holds many space firsts and duration records. It was inhabited for 9 years, 11 months and 22 days, 8 days short of 10 years. Mir was also important in international relations. It would eventually carry on the work of the Apollo-Soyuz test project and would see astronauts and cosmonauts of many nations working together aboard Mir. The American Space Shuttle would become a regular visitor to the station. Mir would also see its share of drama: decompression, fires, and a collision with another spacecraft. But it was none of these disasters that nearly brought Mir down. It would be the collapse of the Soviet Union and the lack of funding. Mir began its life in low Earth orbit February 19, 1986, with a successful launch of the core module aboard a Proton rocket. The modified DOS-based core module weighed 20,100 kilograms and had additional docking ports, 6 in total. 5 in a spherical unit at one end, where other components could be attached. The other end had a single docking port for a Soyuz spacecraft. The core unit contained the basic living quarters for the cosmonauts. Early development was cash-strapped due to the urgency in getting the Soviet Union's Space Shuttle Buran operational. However, funding was redirected back to the Mir project to meet tight political deadlines. The first crew to inhabit the station flew aboard Soyuz T-15 on a remarkable flight indeed. Leonid Kizim and Vladimir Solovyov docked with Mir March 15, 1986, and stayed 51 days, powering up and checking out the Mir's extensive systems. During this time, 2 unmanned Progress spacecraft docked with the station, and the cosmonauts unloaded and stored the supplies and equipment. On May 5th, the 2 men undocked from Mir and traveled for a day to the Salyut 7 space station, still in orbit. They docked and boarded the Salyut station and remained there for 51 days, collecting 400 kilograms of scientific materials and equipment. During this time, an unmanned Soyuz TM-1 spacecraft docked with Mir. Kizim and Solovyov then left Salyut 7 and voyaged back to Mir and docked once again with the space station. They then moved the scientific experiments and equipment into Mir and remained for a further 20 days. The 2-man crew finally left Mir unoccupied July 16, 1986, and returned to Earth. The second crew to Mir arrived in February 1987, and during their stay, the second component of Mir arrived. The Kvant 1, a 10,000-kilogram astronomical and science workshop. Attempts to dock the unit failed twice. A spacewalk by the cosmonauts found the fault to be a bag of garbage stuck in the docking port that had been left by a Progress vessel. With the US shuttle fleet grounded, the Soviets had unfettered access to orbit once again. The Mir space station was open for business. There was a string of 5 Soyuz TM spacecraft arrivals over 2 years, beginning in 1986. 3 were long-term crews and included several cosmonauts from other countries, including Syria, Afghanistan, and France. The European Space Agency, ESA, took advantage of the Soviet capability and began extensive training of their own scientist astronauts for long stays aboard Mir. Meanwhile, the US Space Agency, NASA, did their house cleaning, redesigned the solid rocket booster on the shuttle orbiter, and on 29 September 1988, Discovery lifted off, returning America to space. It carried another TDRS satellite in its cargo bay to replace the one lost aboard Challenger. It remained in orbit for only 4 days, but the successful mission signaled NASA too was back in business. Considered flight-worthy again, the shuttle fleet commenced regular services to low Earth orbit. One of the most exciting missions was the delivery of the Hubble Space Telescope to orbit April 24, 1990. However, the dawn of a new age in deep space exploration is marred when it is discovered that the Hubble's primary mirror is faulty, rendering the optical telescope almost useless. The next Soyuz launch on September 5, 1989 was the beginning of the longest human presence in space to date. Alexander Viktorenko and Alexander Serebrov docked with Mir and prepared it for the next expansion phase. Kvant 2, another 20,000-kilogram module developed from the Almaz unit, was launched November 26th, and after a manual docking, the unit was attached to Mir and provided a new life support system and water recycling capability for the station. It also contained a new larger airlock and a new EVA backpack. The next unit, Kristall 1, which arrived May 31, 1990, was eventually attached opposite the Kvant 2 module, returning equilibrium to the Mir complex. It housed more scientific equipment and materials manufacturing furnaces. It also housed a small but elaborate greenhouse and more astronomical equipment. The Kristall unit also had 2 new docking ports designed for the Buran Space Shuttle, which was eventually scrapped. 2 more Mir components were being readied for launch, Spectre and Priroda. However, the crew aboard Soyuz TM-13, which was launched October 1991, was to be the last launch from the Soviet Union. With the collapse of the communist state and the upheavals, both social and economic, the Mir project was doomed. Spectre and Priroda were both mothballed, and the plans to bring the last crew back to Earth begun. The newly formed Russian Federal Space Agency was broke and could not continue the Mir project. Several decades of research and development was about to fall out of the sky. The United States could see the value in Mir. The years of experience for both engineers and cosmonauts were too valuable to let go. Together with the new Russian Federation, they hatched a plan. In September 1993, the Russian Prime Minister, Viktor Chernomyrdin, and the US Vice President Al Gore announced the plans for a new space station. As part of this long-term project, the US would join Russia in completing Mir and adding facilities to allow the US Space Shuttle to dock, calling this Phase 1 of the new station. The shuttle would provide transport to and from the station. In return, US astronauts would cohabit on board the station. Phase 2 would be the construction of a new, larger facility based on the lessons learned from Mir. What this meant was money. Money to extract the 2 Mir components out of storage, and money to develop a special docking module for the shuttle. 1st June 1995, the Spectre module, weighing a little under 20,000 kilograms, was docked to Mir. The module contained more Earth observation equipment, including atmospheric analysis equipment and surface research equipment. It also had 4 additional solar cells and generated about half of the completed station's power supply. The joint Shuttle Mir program began slowly, cautiously. In 1994, the first cosmonaut, Sergei Krikalev, flew aboard a shuttle. The following year, in February, the shuttle flew within a stone's throw of Mir but did not dock. Next, a US astronaut flew aboard a Soyuz vessel to Mir and remained there for 115 days. Atlantis then made the first docking with Mir in June and transferred Russian crews and supplies and retrieved their astronaut, Norman Thagard. 5 months later, Atlantis returned and added a new docking module for the shuttle. Designed and built by the Russians, it was funded by the Americans. Nominal long-term crew was 3, but at times up to 6 spacefarers called Mir home. She was continuously occupied until August 1999. During this period, Russian cosmonauts were tasked with station running and upkeep. She was looking well worn and lived in after 10 years, and equipment was constantly breaking down. In March 1996, the US began a permanent presence aboard Mir. Astronaut Shannon Lucid began it with a record spaceflight of 188 days. Astronauts and scientists conducted experiments and studied human physiology, life sciences, microbiology, and material sciences. The final Earth Sciences module, Priroda, was added 26 April 1996. Now complete, the Mir space station weighed over 100,000 kilograms. Inside, she looked like a cramped labyrinth of cables and pipes, scientific equipment everywhere. Personal items such as photos and children's drawings adorned the walls.
There's a bungee cord that sort of helps you navigate back and forth. This is Priroda, the new module that came while I was there, and it's full of various scientific equipment. As you can see, there's a glove box, and it just worked outstanding. Actually, everything all the United States equipment that was there in Priroda worked really, really well. Now, this is the node, and everything joins up here. And when, after progress came, Yuri pointed out to me that for the first time in the history of the station of Mir, all the nodes were occupied. That was a new record.
It really was a home away from home. Shuttle STS-79 reached Mir in August 1996. When they finally docked and opened the hatch, they found an astronaut who couldn't wait to come back to Earth.
Ready to open the hatch. And the Mir 22 crew.
Lucid had been kept on Mir 6 weeks longer than planned due to mechanical problems with Atlantis. She was replaced by fellow American John Blaha. Early in the next year, Blaha was succeeded by astronaut Jerry Lininger, who became the first US astronaut to don a Russian spacesuit and perform several EVAs about Mir.
With our Russian colleagues now, and we actually tested out a brand new suit. It was the first time that spacesuit was ever used in space, and so we had a great spacewalk together and good cooperative spirit going. Like I'll tell you, that spacewalk, the whole time it felt like I was falling from the edge of a cliff, and not only falling from the cliff, but the cliff itself, being the space station, was falling the whole time. And so it was a remarkable feeling, and you had to keep yourself under control and talk yourself into saying it's okay to be falling, and seeing the spectacular view of the Earth and the big space station sprawling, all that was just fantastic. So that's probably the memory I'm going to take home the most.
Lininger also survived one of the most dangerous incidents that could happen aboard a space station: fire.
The fire was basically in this region here, with the flame shooting across this way. And therefore, as you can see where the camera is basically where I was at, and we had one other body in front of me. I was passing the fire extinguisher, but we can only get one person in here to fight the fire because of the flame location. And at that time, the other Soyuz was on the other side where Progress is now docked. So as you can see, it would have been very difficult to get through the flame itself to get to to one of the rescue vehicles. And it was very difficult to fight the fire because you could only get one body close enough to the fire.
A backup oxygen generating device caused a fire. The station filled with toxic smoke, which forced the crew to don respirators, some of which were faulty. Some firefighting equipment was also defective or unusable. The fire also blocked access to one of the escape craft. As there were 2 Soyuz attached at the time, due to a crew changeover, there were 6 crew aboard. If evacuation was necessary, only 3 would have survived. However, life aboard the space station returned to some form of normalcy very quickly. Atlantis again visited, and Linninger was replaced with British astronaut Mike Fole in May. His stay aboard Mir was even more eventful and dangerous than that of his predecessor. June 1997, an unmanned Progress cargo spacecraft, M34, was making a regular stop at Mir, bringing in supplies and taking out the garbage. Whilst maneuvering to dock with the Kvant 1 module, the craft lost control and smashed into the station, damaging the Spectre module's solar panels and punching a hole in the Spectre module itself, causing the sudden and potentially lethal decompression of the entire station.
We thought there was a collision imminent. The thought in our minds was we are going to have to bail out, and I was the first one to go per the procedures to the Soyuz, and there I waited. Then, as it became apparent that it wasn't a devastating puncture of the hull of Spectre module, and that we had time to work and try and isolate it, then I came out of the Soyuz, understood implicitly that we were not going to be abandoning quite yet. And we then proceeded to work together. I was Sasha Lazutkin to clear cables and hold a hatch in place over that module's entranceway. We had about 24 minutes of what we call reserve time before we had to be in the Soyuz if we hadn't isolated the leak. And so once we determined that time, and Vasily, the commander, had done that, we knew that we had some time to think carefully, clearly what we were doing and work through the problems of sealing off the leak.
In order to close the hatch to the module and save the rest of the station, cosmonauts had to resort to fire axes to sever power cables, stopping the hatch from closing. This unfortunately cut the power from the solar panels, reducing the overall power to the station.
The Progress had undocked from this end and had flown away for a day and was redocking at this end when they lost control. It appears that as it went by, it went down the Perota side of the core module. This is the Perota module here, and impacted this solar array, which is on the side of the Spectre module, bounced off of that, and then impacted the radiator, which is on the side of the array, and then cleared the station.
2 months later, cosmonauts from Soyuz TM-26 made repairs to the Spectre hatch, allowing the power cables to pass through the closed hatch and be reconnected, returning the station to 70% of their power requirements.
It's a serious situation, and fire aboard an aircraft or spacecraft and decompression are the two most dangerous things that can happen on a orbiting vehicle. So, you know, we've had both of those. At some point, you need to step back again after the dust settles here. You need to do the immediate steps right now, obviously, and make sure we're stable up there. And then you need to step back and reevaluate.
Unfortunately, the Spectre unit had to remain sealed and depressurized for the remaining life of the station. It had major leaks that could not be located. It would seem that Mir's days were numbered yet again.
We will be bringing back some scientific...
2 more NASA astronauts would visit Mir. David Wolf would spend 128 days in space. He was to be the final U.S. astronaut assigned to Mir.
...outside of
But with a change in requirements for all station visitors to be EVA trained and qualified in case of emergency, astronaut Wendy Lawrence was bumped. A suit could not be readied for her in time. The final NASA astronaut to visit was Australian Andy Thomas, who relieved Wolf in January 1998. He stayed for 141 days, performing numerous scientific investigations, and extended NASA's flight record to nearly 800 days of continuous presence in orbit. Ever on the lookout to improve the funding of Mir, the Russian space agency tacitly allowed a private company to seek paying tourists and give them the opportunity to fly to Mir.
As I said, thousands of pounds of material that had to be transferred from the shuttle and then back from the Mir to the shuttle.
It seemed like we had just gotten to the Mir when it was time to say...
Toyohiro Akiyama was a journalist working for a Japanese TV company who funded his flight at a cost of $28 million. He passed basic cosmonaut training and flew aboard Soyuz TM-10 to Mir, December 1990, where he stayed for a week, reporting daily to his TV audience and conducting experiments for Japanese companies. He returned to Earth aboard the next Soyuz flight, TM-11. Having spent 7 days, 21 hours in space, he was the first Japanese in orbit and the first journalist, but was not deemed a tourist because his flight was paid for by his employer. Wannabe space tourist Peter Llewellyn wanted to pay $100 million for the privilege of visiting Mir in 1999, but was declined. Dennis Tito put down $20 million for his chance to fly to Mir for 10 days. However, Mir was no longer an option, and his ticket was upgraded to the International Space Station. I believe that our greatest accomplishments are Sputnik, our first man in orbit, and of course the space station Mir, which was planned to fly for just a short time, only 4.5 years, and has been flying for 15 years. This was a great success and vindication of the engineers' work. The final crew to visit Mir was launched in April 2000. This privately funded mission was a last-ditch effort to see if the station could be rescued from oblivion by private funding. It was not to be, and Russian officials ordered the station down. A Progress spacecraft was docked with the station, and its engines and additional fuel used to deorbit the 15-year-old Hulk. It entered Earth's atmosphere high over the Pacific Ocean near Fiji and broke up. Much of it burned up on re-entry, but some debris managed to hit the water harmlessly 21st March 2001.
Liftoff of Space Shuttle Columbia to broaden our view of the universe through the Hubble Space Telescope.
Houston now controlling the flight of Columbia, the Pioneer shuttle headed for the Hubble Space Telescope. Booster officer confirms a good SRB separation. Guidance now converging. Columbia's onboard computers commanding.
To date, the Hubble Space Telescope had cost over $1.5 billion. It was too much money to throw away on a second-rate optical telescope, even if it was in orbit. Intensive work on the ground put together a rescue plan for the platform, not only to repair the distortions in the primary mirror, but to replace its power supply and other key electronics to up its capabilities for the coming decades. As soon as it reached orbit, the shuttle captured Hubble and pulled it into the cargo bay, where the astronauts set upon her with fervor. This was the second servicing mission for Hubble. The first repair mission occurred in 1993, when Endeavour spent 10 days repairing the orbiting telescope. The primary task was the installation of the COSTAR corrective optics package to overcome the errors in the main mirror.
Without power now for just over 4 hours in the Hubble Space Telescope.
A main camera was replaced with the wide field and planetary camera,
which is temporarily stowed on a mounting bracket on the side.
And the solar arrays were replaced along with their drive electronics. And the 4 gyros that point the telescope at the heavens were replaced. A second repair mission was flown by Discovery in 1997. replacing imaging spectrographs and data recorders.
Spacewalk officer in Mission Control Dana Weigel reports that we're about 25 minutes behind in the timeline.
They also installed a solid nitrogen heatsink to help cool the near-infrared sensors, though this experimental heatsink proved to be faulty, reducing the life expectancy of the unit. In 1999, the gyros and computer were replaced when most had failed, rendering the telescope inoperative. Also added were thermal blanket insulation and a new fine guidance sensor to improve its accuracy. A further mission in March 2002 installed a new instrument, the Advanced Camera for Surveys, or ACS. The mission also revived the low-temperature NICMOS sensor, which had run out of coolant. A new cooling system was added to stabilize this system. The solar arrays were replaced for a second time with smaller, more efficient solar panels. The power distribution system was replaced, and with this additional power, all instruments aboard Hubble could be run at the same time.
The handle and install the pit pin, and the notice to apply pressure down here. Okay, don't push anymore, Rick. I'm not. Okay, thanks. The notice to apply pressure to doors while engaging the latch bolt. We've given it new eyes to see deeper into the universe than it's ever been able to see before. And I think you'll see that people at the Space Telescope Science Institute, universities all around the world, amateur astronomers, young and old, will be able to enjoy the beauty and inspiration that these new pictures from Hubble will bring.
Hubble turned her eye towards the heavens, and what spectacular images she saw. Edwin Hubble was born 20th of November 1889 in Missouri, USA. He studied at the University of Chicago, focusing on mathematics, philosophy, and astronomy. His work on the nature of the universe was profound, proving to others the existence of galaxies besides our own Milky Way, and defining what was to become known as Hubble's law. The degree of redshift observed from a galaxy is proportional to the distance of that object, helping to prove the universe is expanding. He opened the eyes of astronomers and the public alike. His namesake in low Earth orbit is doing much the same today. It's the golden eye of popular astronomy. The idea for a space-based telescope harks back to the beginning of space flight and the founding fathers of rocketry. Hermann Oberth wrote about launching a telescope into orbit aboard a rocket in 1923. In 1946, prominent astronomer Lyman Spitzer pushed for a space-based telescope and did so for much of his career. He published details of how more effective a telescope would be without having to peer through a thick atmosphere, particularly in the infrared and ultraviolet regions of the spectrum. The dream was achieved in 1990, when the Hubble Space Telescope was placed in orbit by the Space Shuttle Discovery. The HST is a collaboration between NASA, the European Space Agency ESA, and the Space Telescope Science Institute. The HST was the first of the 4 Great Observatories project, a program to launch 4 telescopes into space, each with the capability to see in a particular bandwidth of the electromagnetic spectrum. Hubble was designed to see in the visible and near-infrared ranges of light. It weighs 11,110 kilograms and houses a 2.4-meter diameter Cassegrain reflector. Attached to this telescope are several camera and sensor packages, including optical survey cameras and infrared and ultraviolet spectrometers. It is the only telescope designed to be serviced in orbit by astronauts and has been repaired, serviced, and modified several times already. After first arriving in orbit, the primary mirror was found to be faulty from manufacture. Starlight seen here is diffused and not a pinpoint as it should be. After the first repair mission by the shuttle, the mirror fault was corrected and the starlight brought into tight focus. The Hubble Telescope revolutionized our visual appreciation of the universe. The fourth and last repair mission to Hubble was conducted mid-2009 by the Space Shuttle Endeavour. This mission was to extend Hubble's useful life by another 5 years by replacing all 6 guidance gyros, installing new batteries, and replacing faulty storage and communications systems. They have also installed 2 new instruments, the Wide Field Camera 3 and the Cosmic Origins Spectrograph. The Wide Field Camera is state-of-the-art and will improve the telescope's sensitivity by 10 to 30 times the current level. They have also repaired 2 onboard instruments that failed some time ago, the STIS, or Space Telescope Imaging Spectrograph, and the Advanced Camera for Surveys, or ACS. They have also attached a soft capture mechanism to the base of the telescope. This will be utilized sometime in the future to help deorbit the telescope. The ACS was Hubble's most important camera. Able to see in the visual and ultraviolet wavelengths, it was the camera responsible for the ultra-deep field image, NASA's deepest view of the cosmos yet. Once again, Hubble, fitted out for more work, is released from the shuttle cargo bay and sent on its way. With its new equipment, the Hubble will be able to see further into the distance than ever before. The Hubble has helped discover a new phenomenon that needs further observation.
The other thing is to probe this very mysterious phenomenon that's called dark energy, which is the catchphrase for a force that is not understood in terms of the physics, a force that is accelerating the expansion of the universe.
The Hubble telescope has always been a work in progress, originally designed to be serviced in orbit by Space Shuttle astronauts. The reasoning? Such complex apparatus in so hazardous an environment was indeed going to fail at some point, no matter how well designed or built. More importantly, the rapid improvement in technology. Electronics hardware aboard the Hubble was outdated almost immediately it was put into orbit, such as the speed of microelectronics evolution on Earth. But through the capabilities of the Space Shuttle, Hubble has been continuously repaired and improved, each time allowing the eye in the sky to see deeper, further away in space and further back in time, back to the beginnings of the universe. Peering into the hidden places where dust and gas form stars, like this nebula in the constellation of Orion. To turn blurry smudges of light between the stars into massive swirling galaxies containing billions of stars in their own right. But of all the images collected by Hubble, the one of most importance and grandeur is that of the Deep Field Survey, where Hubble was pointed at what looked like a blank part of space. After a long exposure time, scientists were amazed at what Hubble found. From the dark depths came hundreds of galaxies, each a unique mass of billions of stars. This randomly selected section, a core sample of the universe, indicates that the universe is full of billions of galaxies some billions of years old, and many never seen before Hubble. Hubble was then pointed in other directions and let exposures of up to 10 days be made, Hubble collecting all the light possible. It too revealed galaxies upon galaxies, filling the dark void. The further away, the older the galaxies, revealing a steady evolution of the many types of galaxies, going back almost as far as the Big Bang when the first galaxies formed. What else will Hubble discover? Time will tell. The Hubble Space Telescope was the first of 4 great observatories that NASA put into Earth orbit. The second was the Compton Gamma Ray Observatory. Named after Dr. Arthur Compton, a Nobel Prize winner in physics, it was launched aboard Atlantis in April 1991. It was the heaviest telescope payload to date, weighing 17 tons. The telescope was a gamma ray detector and had 4 instruments that covered a wide range of the upper electromagnetic spectrum. These instruments were the Burst and Transient Source Experiment, the Oriented Scintillation Spectrometer Experiment, the Imaging Compton Telescope, and the Energetic Gamma Ray Experiment Telescope. These 4 experiment packages had sensitivities 10 times more powerful than any previously flown gamma ray detection equipment. Some of its mission highlights were the complete mapping of the Milky Way, discovery of the bursting pulsar, and discovery of blazar-active galactic nuclei as the main source of high-energy gamma rays. Normally, a satellite would be left to decay naturally from orbit, but due to the size of the Compton satellite, it would not burn up completely in the atmosphere. NASA had to redirect the satellite deliberately into the atmosphere with a controlled re-entry that ensured its safe destruction. The telescope was deorbited in June 2000 after serving 9 years in operation. The third great observatory was launched 23rd July 1999. The Chandra X-ray Observatory has been another outstanding scientific instrument in unraveling the secrets of the universe. Named after Subrahmanyan Chandrasekhar, the Nobel Prize-winning astrophysicist, The telescope sees in the X-ray spectrum of light and can study the regions of the universe where remnants of exploded stars still emit high-energy particles. The telescope resides in a high elliptical orbit above the Earth's belts of charged particles, giving it a clear view of the X-ray universe. The telescope captures the incoming X-rays and focuses them down to half the width of a human hair, and 4 instruments on board then record and analyze the high-energy light. For the first time, a multi-wavelength, 3-dimensional reconstruction of a supernova remnant has been created. This stunning visualization of Cassiopeia A, the result of an explosion approximately 330 years ago, uses X-ray data from Chandra and other resources. It begins with an artist's rendition of the neutron star previously detected by Chandra. The green region is mostly iron observed in X-rays. The yellow region is a combination of argon and silicon, including jets of silicon, plus outer debris seen in the optical. The red region is cold debris seen in the infrared. Finally, the blue reveals the outer blast wave, most prominently detected in X-ray. Another example of X-ray data combined with other telescope observations revealing previously unseen and intriguing structures. At the center of this image is a very young and powerful pulsar, known as PSR B150958. Pulsars are rapidly spinning neutron stars that are created when massive stars run out of fuel and collapse. This pulsar is spewing energy out into space and creates this beautiful X-ray nebula, including a structure that resembles a hand. Finger-like structures extend to the upper right, transferring energy into knots of material in a neighboring cloud of gas and dust that is seen in other wavelengths. This makes these knots glow brightly in X-rays, which is why they appear red and orange in this Chandra image. Astronomers think that this pulsar is about 1,700 years old and lies about 17,000 light years from Earth. These eyes in the sky can see further afield than even our imagination. The fourth and final one of the great NASA observatories is the Space Infrared Telescope facility, later dubbed the Spitzer Space Telescope. Named after Lyman Spitzer, the driving force in space-based astronomy, it was launched aboard a Delta rocket 25th August 2003. The Spitzer telescope is an infrared detecting telescope able to see in the wavelengths between 3 and 180 microns, or the thermal range of the electromagnetic spectrum. The largest infrared scope launched into space so far, it consists of 3 cryogenically cooled science packages and a 0.85 meter diameter telescope. The cooling of the infrared detectors to near absolute zero, or minus 273 degrees Celsius, is essential to pick up the faint heat from distant stars and galaxies. To protect the scope from solar and Earth thermal radiation, it carries a solar shield sheltering it from the sun and is in an Earth-trailing solar orbit. This type of orbit far from Earth allows the telescope to cool rapidly and reduce the need for extra coolant that would be required if in a close Earth orbit like other satellites. The Spitzer telescope has done for infrared astronomy what the Hubble did for the visual light spectrum, with highly detailed images for galaxies and clusters of stars in the near infrared, revealing many hidden secrets of the universe. Our classic vision of spiral arms in galaxies gives way to a spectacular infrared view of the dust within. Spitzer's infrared view is almost like an X-ray of the dusty bones within the arms and disks of galaxies. Infrared light reveals the amazing contrasts between the 2 interacting galaxies, known as the whirlpool. The galaxies in our local neighborhood have a wide variety of shapes and structures, that Spitzer's unique view helps us see more clearly. The dusty ring encircling the Sombrero galaxy stands out vividly in infrared light. Combining the visible Hubble and infrared Spitzer views gives us an amazing composite, expanding our own vision of this object. A popular constellation in the night sky is Orion the Hunter. Hanging beneath its distinctive 3 belt stars is a glowing patch known as the Sword of Orion, or M42. At a distance of 1,300 light-years, this nearby stellar nursery is easily visible to the naked eye. But for astronomers studying the Sword of Orion, visible light alone is not enough to reveal its secrets. We see only the small patches where young stars heat the surrounding gas and make it glow. The bulk of the Orion cloud complex is a mostly dark swathe of dust and gas containing the mass of about 100,000 suns and spanning 250 light-years. The infrared eye of the Spitzer Space Telescope can see this dust directly and identify the vast population of infant stars buried within. Spitzer can find young stars by detecting the infrared glow from their surrounding dusty disks. The very youngest stars are gobbling up material from their disks and growing larger. Observing the Orion Nebula with this new capability reveals a brilliant cluster of 1,000 stars residing in a bowl-shaped cavity in the larger cloud. 4 of these stars, known as the trapezium, are massive giants. Their dust-destroying ultraviolet light alone was enough to hollow out most of this cavity. The most prominent infrared feature here is the next generation of massive stars, which are completely hidden in visible light behind a fold of dust. Their expanding shock waves heat the gas around them, producing a brilliant green glow. Most of the stars in this ultraviolet-drenched region have dust disks, and astronomers are studying how this affects the potential for planet formation. Looking to the north of the Orion Nebula, we find a colorful region laced with dark veins of dust. The stars here appear to be forming in an orderly progression, with older stars on the left and younger ones on the right. Many of the green blobs here literally point to nearby star formation. As infant stars feed on their surrounding disks, they eject fast-moving jets of material. When these jets slam through the surrounding cloud, they produce shock waves that glow green in Spitzer's vision. Even to the south, where there are no massive stars lighting up the dust, modest-sized stars are clearly forming in abundance. The team of scientists exploring the nebula have identified about 200 growing baby stars and over 2,000 young stars with planet-bearing disks. That's a lot more than we knew before, but the demographics of this census are even more important now we have a more complete picture of the star-forming environment. The Omega Nebula, or M17, is another star-forming region in the constellation of Sagittarius and is about 6,000 light-years away. In infrared light, the dust fades into transparency and inner details are revealed. A cluster of huge stars lies at the heart of the nebula. Some of them are over 40 times as massive and 100,000 times as bright as our sun. This infrared technology is allowing us to peer closer into the secrets of the universe and even detect other planets circling these hidden stars. As each of these great observatories completes its mission, newer, more advanced replacement satellites are being planned and launched. We shall see what marvels they will discover. For millennia, the mysterious travelers of the solar system, comets, were thought of as omens of things to come, usually bad. Ancient texts and illustrations mark the passing of these lights with tails streaking across the night sky. They are often linked to tales and legends even of religious significance. In more enlightened times, comets were passed off as elegant balls of primordial ice and early planetary debris, heated by the sun to form their cometary tails. Like the transient asteroids dislodged from the distant belt of asteroids between the orbits of Mars and Jupiter, comets were difficult to study and little understood. When the connection was made between mass planetary extinctions of life on Earth and the strike by an asteroid, serious thought was given to these rocks in space.
There's still a lot of controversy. We as scientists, we've often had, quite a hard time coming to the notion that, rocks the size of a mountain might fall out of the sky and do life, some serious harm. Then 20 years ago, things started to change when we started to find some evidence for the death of the dinosaurs being caused by an impact. And since then, it's been suggested, a number of the other big changes that have happened to the history of life may have been caused by impact. So it's become a topic of intense study. And the arguments are still there as to whether an impact can cause a mass extinction on Earth, can affect the course of life. But it's much more widely accepted that we can't study the Earth in isolation anymore. We have to look at its place in the wider cosmos and the rest of the solar system.
To study these objects from afar with telescopes has been daunting. There was only one answer: to send unmanned probes out to get a close-up look at these comets and even take samples. Asteroids could be radar mapped and, if one dared, even landed on. Scientists and engineers around the world rolled up their sleeves and began planning some bold missions. The first attempt to fly by a comet occurred in 1985. The International Cometary Explorer, or ICE, passed the comet Giacobini-Zinner. The following year, it passed through the tail of Halley's comet in March. In fact, 1986 was a busy year for scientists. The year Halley's comet was on a return trip close to Earth, an opportunity not to be missed. Several probes from several nations were launched or tasked after their primary missions to intercept Halley. The Soviet Vega 1, its primary mission to visit Venus, passed within 8,889 kilometers of the comet 6th March 1986 and took 500 pictures of the nucleus. Passing through the gas cloud surrounding the coma, the probe did not suffer any system failures. The probes studied the many parameters of the comet, including density, shape, and composition. Sakigake, codenamed MST-5, was Japan's first deep space probe, and the first long-distance probe launch by a nation other than the US or Russia. It was part test vehicle for the future Successor probe to be sent aloft some months later. Successor was identical to Sakigake in construction, but included imaging hardware in its instrument package, including a UV imager. Launched August 18, 1985, it began imaging Halley by November. Its closest approach was 151,000 kilometers. It suffered only 2 dust particle impacts. ESA's successful Giotto was launched 2nd July 1985. This was the European Space Agency's first deep space probe. Once Halley had passed and returned to the edge of the solar system, the public and scientific excitement died down. Then, in 1994, something unexpected happened that brought attention to the issue of comets hitting planets. A little-known small comet, Shoemaker-Levy 9, was on a collision course with the planet Jupiter. All eyes and telescopes were turned to witness this event. Due to the gravitational forces of the mightiest planet in our solar system, the comet was torn into 21 pieces, and like machine gun tracer bullets, the string of cometary debris smashed into the Jovian giant with unprecedented explosive energy. Between the 16th and the 22nd of July 1994, At 60 kilometers per second, the pieces of comet struck the planet.
If you look at all the solid bodies in the solar system, you will see that they're covered in craters, and that does demonstrate that back at least billions of years ago, there must have been a period of time when the sun and planets were forming, when these collisions were really very common.
The Jupiter-bound probe Galileo was en route at the time and had the closest cameras and sensor equipment. Unfortunately, the comet fragment struck the planet on the far side, blocking the event. However, the effects on the clouds of Jupiter were clear, and infrared sensors picked up the residue energy signatures. It is speculated that each fragment would have left a crater the size of Earth.
There are still very much debates about exactly, when the impact rates were at their highest, exactly which bodies have been most affected. Also, there's a kind of discussion which almost takes on a philosophical role as well about whether or not those impacts helped or hindered life. I mean, clearly, if we're on Earth today and we had an impact of a giant asteroid, it would be very bad news. But equally, in the past, it may well be that objects like comets, which are largely made of a lot of water ice, collided with the Earth and may well have been responsible for filling the oceans of the Earth and actually helping life to begin.
The Jupiter-bound spacecraft Galileo that witnessed the Shoemaker-Levy collision was also the first probe to encounter an asteroid close up. Launched from the Space Shuttle in 1989, its primary mission was to reach Jupiter, orbit, and launch a probe into the Jovian atmosphere. En route, the opportunity arose for a closer look at the mysterious asteroid belt. It managed to pass close to two asteroids, 951 Gaspra in 1991 and in 1993, 243 Ida. Gaspra, an S-type asteroid, journeys around the innermost section of the asteroid belt. Ida, with an average diameter of 12 kilometers, was discovered to have a satellite of its own. Both these main belt asteroids orbit the Sun every 4.84 years. Ida tumbled at a stately speed of 1 revolution every 4.63 hours. Eros is an asteroid that passes close to Earth on its eternal orbit of the Sun. NASA launched the Near-Earth Asteroid Rendezvous probe 17th February 1996. Dubbed Shoemaker after the scientist Eugene Shoemaker, its objective was to intercept and study 433 Eros. Scientists wanted to know exactly how big, how dense, and what the composition of the asteroid was. Even the magnetic field was studied. The probe itself housed an X-ray gamma-ray spectrometer, infrared imaging spectrometer, a magnetometer, laser rangefinder, and multispectral camera. The package weighed 56 kilograms and was powered by solar panels. En route to 433 Eros, NEAR was in a hibernating state, but was powered up as it neared another asteroid, the 61-kilometer diameter wide 253 Mathilde, in June 1997. The probe passed within 1,200 kilometers of the small asteroid, returning imaging and other instrument data. On 3rd July, it made an engine burn, altering its trajectory, and the probe swung by Eros in January 1998, passing within 540 kilometers of the rock. The first attempt to orbit the asteroid failed due to a software failure, but a second flyby and maneuver in January 1999 set NEAR on an orbit intercept. Eros was encountered 14th February 2000. The S-type asteroid measured 13 by 13 by 33 kilometers. NEAR made several orbital changes while studying the asteroid, bringing the probe to within 35 kilometers. In January 2001, the probe made several closer orbits down to just 2 to 3 kilometers. On February 12th, the probe slowed its descent and touched down on the surface of the asteroid, the first to do so. To the surprise of the scientists, the probe survived the landing, and it continued to operate its sensors, in particular its gamma-ray spectrometer, which operated very well at such close range.
From our landing area in Utah.
NASA sent a probe to fly by Comet Wild 2 to collect samples of its cometary tail and return them to Earth. February 7, 1999, the probe Stardust was launched on a round-trip mission of 5 billion kilometers. January 15, 2006, and the probe ejected its sample return capsule that landed in an Air Force training facility in Utah, USA. The mission was so successful that another is planned to intercept Comet Tempel 1. The Japanese space agency launched a sophisticated probe dubbed Hayabusa. Its mission? To return a sample of asteroid material to Earth. It was the first probe specifically designed to touch down on an asteroid and then lift off with core samples, returning them to Earth for analysis. Launched 9th May 2003, the 2-year, 4-month journey took the probe to its target, a near-Earth asteroid called 25143 Itokawa, a small rock with a diameter of 540 meters and length 270 meters. The Hayabusa spacecraft rendezvoused with the asteroid and studied its shape, spin, composition and color, as well as its density and topography. In November 2005, it attempted to touch down and take samples, but failed to do so. However, scientists believed that sufficient dust particles were collected. The probe was sealed and sent on its way back to Earth. It is expected to arrive mid-2010. The two largest known asteroids in the main belt are Vesta and Ceres. NASA launched Dawn, a robotic probe, to investigate these two giants September 27, 2007. It aims to reach Vesta between 2011 and 2012. Dawn will become the first probe to orbit one object, then, under power, move off and orbit another planetary object. All previous multi-target probes have been flyby missions. The next stage of investigating the origins of comets was launched aboard a Delta II rocket on January 12, 2005. Previous missions had been flybys of comets. This one, dubbed Deep Impact, was to hit the surface of the comet with a probe and study the interior debris ejected from the collision. The impact probe consisted of a copper core of 370 kilograms, plus targeting sensors and a camera. The flyby section is 3.2 by 2.3 by 1.7 meters, and housed two main cameras, one high and one medium resolution, plus infrared spectrometer and other scientific packages. The target was 9P, Tempel, 174 days travel time. The probe reached its vicinity at 103,000 kilometers per hour after traveling 429 million kilometers. The impactor separated and maneuvered itself into the path of the comet. 24 hours later, at a speed of 37,000 kilometers per hour, the probe hit the comet with the equivalent energy of 4.7 tons of TNT.
Subsequent impact with the nucleus. Now 2 hours out, the impactor basically starts its own navigation and control, performs 3 trajectory maneuvers, and then impacts the comet, creating the crater.
Scientists believed it was sufficient energy to dig a crater 100 meters wide and eject sufficient debris to analyze the composition of the comet's interior. Telescopes and sensors from several ground and space-based observatories witnessed the event, including ESA's Rosetta probe, which was passing by at 80 million kilometers. It utilized its ALICE scientific package to analyze the dust cloud from the impact with its ultraviolet sensors.
The next video shows the impactor going in and shows the view from the flyby. There's the impact, and there we have gone by. And it's all over. We get one chance, lasting 800 seconds, to take all of the key data from impact until we've flown past. And the challenge of getting all this to happen autonomously has been the really big effort that's gone on over the last couple of years.
After the success with their first probe, Giotto, ESA set about a grander project. Rosetta would rendezvous with the comet 67P Churyumov-Gerasimenko. Once in position, Rosetta will study the comet's nucleus and its surrounding environment for 2 years. It will also deploy a probe to soft land on the comet's surface, one of the most challenging tasks ever attempted in space. Once the probe has landed, Rosetta will continue to follow the comet as it approaches our Sun. The second and successful launch occurred March 2, 2004, aboard another Ariane 5 rocket from Europe's spaceport in Kourou, French Guiana, the rendezvous now scheduled for 2014. The journey to Rosetta's final destination involves several complex flybys of other planets. It will swing by Earth a year after launch, then Mars 2 years later, followed by another Earth flyby, and in September 2008, it passed by the asteroid Steins. The flyby opportunity of an asteroid could not be missed, and considerable effort was put into getting as close to the asteroid as possible without endangering the primary mission. 2009, another swing by Earth, and then Rosetta encounters Lutetia, another asteroid, the following year. Then in 2014, the comet rendezvous will occur. The probe itself is in 2 sections. The main spacecraft is 2.8 by 2.1 by 2 meters, with 2 14-meter solar panels and 1,670 kilograms of maneuvering propellant. It houses 11 scientific instruments, all designed to face the comet in the primary phase. It will then rotate to release the 100-kilo landing probe dubbed Philae, which will carry 11 science experiments.
And comets are the most pristine materials there are available in the solar system.
Planned lander operations are scheduled for 10th November 2014. Rosetta will be a mere 1 to 2 kilometers from the comet's surface. As the lander touches down on the comet's surface, it will fire 2 harpoons into the surface to anchor the probe in the low gravity. Self-adjusting landing gear will keep it upright on any terrain, and then the landing feet will each drill into the surface, permanently fixing the probe on the surface.
There basically is no gravity with a cometary body this size, so technically you probably don't land on it, you have to dock with it. And to save yourself bouncing off, I mean, what happens with the lander is that it fires some harpoons out from the bottom of its feet when it actually lands there and anchors itself down. It has to do that. Yeah, the technological challenges about designing something that could land on something as hard as concrete or as soft as marshmallow are enormous, but, you know, we like difficult.
The lander will focus on the study of the composition and structure of the comet's nucleus material, including microscopic studies of individual grains. The end of the mission is scheduled for December 2015. There are many thousands, if not millions, of various sized rocks that make up the asteroid belt. Asteroids are continuously orbiting outside this ring in various orbits as well. These are called near-Earth objects. A team of scientists are constantly on the watch for these objects, cataloging and tracking them to determine if any could be a threat to the Earth.
2029, an asteroid called Apophis is only going to miss us by about 20,000 miles. That sounds like a lot, but it's only about 3 times the diameter of the Earth. It's going to pass much closer than the Moon, and in fact, it's going to pass closer to the Earth than the geosynchronous communication satellites above the Earth.
In the cosmic scale of things, that is uncomfortably close indeed. If sometime in the future an Earth-impacting asteroid is detected, it would be highly feasible to deflect the object from its course with accurately delivered nuclear explosives.
It is conceivable and that a spacecraft could be sent up with some sort of explosive on board or some sort of other means to deflect the object from hitting the Earth, to change its orbit very slightly.
If achieved, such an event would mark an evolutionary step for mankind and the planet Earth, which has suffered at least 3 major extinction events, most likely due to asteroid impact. By stopping another such event, man will have forever altered his and the planet's cosmic destiny. Following on from the successful Russian Mir space station program, and as part of the joint agreement, NASA and the Russian Space Agency began construction of the International Space Station. Rapidly, other nations became involved, including Japan, Canada, the European Space Agency, Brazil, and the Italian Space Agency outside the European grouping. Even China has shown an interest in involvement. In-orbit construction began in 1998 and is currently the largest orbiting structure ever built and will continue to grow until completion in 2011. The ISS has been continuously manned since November 2000 and will continue to be so for the station's planned lifespan of 17 years. Positioned in low Earth orbit, approximately 350 kilometers in altitude, and traveling at a speed of 27,700 kilometers per hour, the ISS now represents man's permanent presence in space and is expected to be replaced by the time of its demise to maintain this uninterrupted presence. The first component of the station was the Russian Zarya. A direct development from the Mir program, it might have flown with Mir if the station had been saved. Launched aboard a Proton rocket, 20th November 1998, this module provided electrical power, storage, propulsion, and guidance for the station during its early assembly. The second piece of the puzzle, Unity, was lifted to orbit aboard the Space Shuttle Endeavour a month later. The Unity module was a node module connecting the Russian and American parts of the station together and providing fixing points for future external trusses and berthing locations for other planned US modules. The third and most critical module arrived July 2000 aboard a Proton rocket. The Zvezda unit was the station's service module, providing the main living quarters for a crew. This large unit also provided environmental systems, guidance control and docking facilities for Soyuz, Progress and other unmanned vehicles. The station was now able to support a crew, and a Soyuz spacecraft lifts Expedition 1 to the station. The three-man crew consisted of astronaut Bill Shepard as commander, with Russian cosmonauts Yuri Gidzenko and Sergei Krikalev. They would remain aboard for 136 days until relieved by the second expedition crew. The shuttle returned with the first of two truss elements, forming the base of the integrated truss structure. Expedition 2 crew was commanded by cosmonaut Yuri Uzachev, along with astronauts James Voss and Susan Helms. Their stay was longer, at 147 days. Six months later, Atlantis delivered the Destiny module to orbit. This would be the primary research facility for general experiments. Destiny also contained an optically perfect window, the largest ever flown at 51 centimeters. Destiny would also provide additional mounting points for the station's integrated truss structure. Atlantis returned 6 months later to attach the Quest module. Quest was the primary airlock for the station, providing an equipment section to house US and Russian Orlan spacesuits and EMU equipment. The other section, the crew lock, was to allow astronauts and cosmonauts access to the outside of the station. A Canadarm was installed soon after, allowing for improved module manipulation and general construction work. Only 2 months later, the Pirs docking node arrived, providing additional docking facilities for Soyuz and Progress spacecraft. It also provided additional room for Russian Orlan suits and EVA equipment.
10, 9, 8, 7. We have a go for main engine start. 5, 3, 2, 1. We have booster ignition and lift.
January 16th, 2003. STS-107 and Space Shuttle Columbia take off on the 113th shuttle mission with a crew of 7. They spend over 15 days in orbit, with Space Hab in the cargo bay. Unbeknown to astronauts, the craft had been damaged by falling debris on takeoff. Tragically, she does not survive the fiery re-entry to air. NASA loses her second space shuttle and crew of 7. Major construction work on the space station is halted for 6 years.
3, 2, 1, and liftoff of Space Shuttle Atlantis to assemble the framework for the science laboratories of tomorrow.
July 2005 marked the return to space of the space shuttles. However, the fleet was grounded a short time as more launch debris issues were discovered. It wasn't until Atlantis flight STS-115 in September 2006 that construction operations on the station recommenced. Atlantis brought with it the second set of solar arrays to help power the station as new modules are attached. The second node module was flown aboard Discovery in October 2007. This unit contains 6 berthing points for other modules and the PMA-2 docking adapter for the shuttle. Harmony also provided additional power and data handling capability. The European Space Agency's module was dubbed Columbus and was launched aboard Atlantis February 2008. A research facility, it is designed to accommodate several sciences, including biology, biomedical research, and fluid physics. Exterior attachments mounted on the Columbus allow for power and data connection to exposed experiments. Future attachments will include the study of quantum physics and cosmology. Weighing 10,300 kilograms, 7 meters long and 4.5 meters in diameter, the Columbus is the largest single contribution by the ESA to the station. The module cost 1.4 billion euros to develop and put into orbit. The Japanese contribution to the station is also quite substantial, with their Kibo Experiment Module Laboratory. It is the largest single ISS module, consisting of two major components: the Experiment Logistics Module, or ELM, and the larger PM, or Pressurized Module. The PM is the core of the laboratory to which the ELM is attached. This laboratory can carry out research into space medicine, biology, Earth observation, materials production, biotechnology, and communications research. The external palette allows for experiment packages' direct exposure to space and is managed with its own manipulator arm, the JEM RMS. At this time, the station's construction is at 81%. Living space aboard is nearing 1,000 cubic meters. A full-time crew of 3 will shortly be doubled. The station has been in orbit for 11 years and orbits Earth every 91.5 minutes. Currently, the station is 73 meters long with 10 pressurized modules, and the solar array is 102 meters wide. Soon the Tranquility module will be attached. It will provide additional life support, adding berthing points and a windowed cupola. Recently, the crew commander of Expedition 18, astronaut Mike Fink, conducted an impromptu tour of the amenities of the space station.
Okay, here we are at the very front end of the International Space Station. This is the forward end of Node 2, and this is right behind this hatch is the PMA, pressurized mating adapter, to which the Space Shuttle docks whenever the next Space Shuttle comes. We will stop at the Kibo module here, the Japanese pressurized module, and the Japanese logistics platform. We'll stop back there in a second. We'll take a look in the Columbus module, pride of the European Space Agency, and our pride too. This is the SIBO rack, which is for cell biology. And then we have a fluid rack, Urutai. Let's take a quick look out the window before it gets dark outside. We're going around the world every 90 minutes, so we get to see a lot of sunrises and sunsets. Oh my goodness, it's beautiful up there. So this is looking out the port side of the space station, and we're actually also on the front side, so front port side of the space station. And okay, so now fly with me. We're going to go to the Columbus module. Here we are in the Columbus module. You can see it's also spacious. It's also cluttered because it's a great place to store things or temporarily send back to Node 2. We'll take a quick look what else we have here. We have my work area. It's a little bit cluttered right now, but this is kind of my desk. It doesn't sit out horizontally, but it has everything I need on it. No, Yuri's been busy unloading the Progress. We just finished an EVA, so things here in the functional cargo block are very functional right now and very cargo-y. So you can see things are just really, really full here in the FGB. As we leave the FGB here, and go into the docking compartment. Docking compartment is another one of those vertical looks, and it's kind of a misnomer. It's not just docking compartment, but it's also a airlock. So Yuri and I went out in these two spacesuits a few weeks ago and went to open space and had a spacewalk. We're going to take a look outside. And this is the hatch that I opened up and went outside for a spacewalk. And we're looking aft of the space station. There's a ladder, some solar panels. We're looking at the service module. Zvezda. And looking at our beautiful planet Earth. Let's see if we can get a nice little view here of Earth. A little small treat. There's no tour of the space station would be complete without it. This is our eating area. There's our table. And we're just getting ready for lunch. There's our water dispenser right there, Russian style. And our controller for the water dispenser. There's Yuri's room off to the side. You can see he has a sleeping bag right there hanging on the wall, and a computer right here so he can call on the telephone, write email, and read books. And relax in the evenings a little bit, because we have long days up here. This is a surprise visit that you guys are paying on us today. So things aren't cleaned up, but they're real. This is exactly how we work and live in space. And that'll wrap up the tour. This is the International Space Station. A very good example of what human beings can do when we work closely together.
The robot arm is a work platform to...
Tranquility will be the last of the US modules to be attached to the ISS. It will house an advanced life support system to recycle water and generate oxygen for breathing. Tranquility will also provide 4 more attachment locations for pressurized modules or spacecraft and a permanent berth for the station's cupola. Of course, the ISS is not just a large engineering platform, it is a scientific research laboratory. A laboratory with unique capabilities not possible to replicate on Earth.
Well, the gee whiz thing is the zero gravity. Having a long-term laboratory with zero gravity is very unique, and I think it's one that I hope that we will reap the benefits from in the future from a scientific perspective in a much more active way.
The space station makes us think about systems and operations in a different way. For example, Don Pettit did some Saturday morning science activities where he took essentially a paper clip and he was going to put a soap film on it and then make a soap bubble and then look at that in space. Well, he made the paper clip and then dipped it in some water, and it turned out it actually made a thicker film than a soap film bubble, but it made a thin film bubble just like it would with soap on it, but it didn't require soap because it was zero gravity. So then he took that water bubble kind of thing, and then he put some salt in it from his lunch kit, and then grew some thin film or thick film crystals in 2D. He then shared that with some of his physics professors down on the ground, and all of a sudden they started thinking about, well, we can do some pretty clever things in space without gravity. So again, he triggered that portion of the imagination we don't often think about.
The completion of the ISS will include the cupola observation module for the crew to operate robotic operations and for Earth observation. Also, the MLM, or Multi-Purpose Laboratory module, will be the Russians' main research facility aboard the ISS. It will study microgravity. The module will also contain additional storage facility, a crew rest area, and additional backup attitude control for the station. Several pressurized modules, though, have been cancelled, including the centrifuge accommodation module, which would have provided some artificial gravity, and a centralized sleeping facility. Also cancelled are several Russian research modules. Also in development was the CRV, or Crew Return Vehicle. A small lifting body, the X-38 was to be an autonomous crew return vehicle for emergencies. The program was cancelled in 2002. One program not scrapped, however, was the ESA's ATV, or Autonomous Transfer Vehicle. The ISS requires regular cargo transfer. The ATV will be an unmanned autonomous cargo delivery system scheduled to arrive every 17 months with 7.7 tons of cargo. Although unmanned, it will be able to dock independently of remote control.
What is unique about Jules Verne, the first ATV, is the fact that it does an automatic rendezvous in a fully autonomous manner, as opposed to Progress or Soyuz, which are the only other space vehicles, Russians, to do automatic rendezvous, but where the vehicle needs cooperation of the station. In the case of ATV, it recognizes by itself where to go.
The first vehicle was dubbed Jules Verne and successfully docked with the station, proving its autonomous abilities. It will not only be able to transfer cargo and supplies, but also provide propulsion to the station and lift its orbit when necessary. One current operation that will soon be halted is the tourist trade. With the crew upgrade at the station from 3 to 6 permanent residents, there will be no more spare seats aboard the Soyuz spacecraft. These had been filled by a company called Space Adventures that would fill the empty seats with paying customers. There have been 6 tourists all up, each paying the tidy sum of $25 million US for the privilege. For the money, they received a ride up and back aboard a Soyuz space vehicle, plus food and board, with a view from 7 to 26 days, depending on flight schedules. They had to go through extensive training to qualify for the flight, but still they were restricted in their movements due to the sensitive scientific work being carried out in some modules. With this avenue of tourism now closed, it will be up to other more commercial ventures like Virgin Galactica to provide the obvious need for space tourism. The orbiting laboratory is the beginning of the permanent human habitation of space, and soon the wider solar system. It will be the base to develop new technologies and techniques to live in the harsh environment of space. The next generation spacecraft will be assembled in orbit for the long-haul missions to Mars and other planets. The ISS will be the stopping-off point for man's return to the Moon in the next decade and the manned journey to Mars soon after. As with all space programs, there are scientific and technological spin-offs that will benefit man at home. New methods of recycling our waste product, new ways to generate electricity or improve the efficiency of existing technologies, new ways to manage our carbon emissions. New materials and processes that cannot be manufactured on Earth hold great promise for advances in communications technology. Biological and medical science can gain as well with the production of new medicines and the growth of research specimens in zero gravity. With the close observation of Earth and ongoing program, it is now more important than ever to watch and learn how the planetary systems function and how rapid changes are occurring. Observation of the Sun from orbit can help us understand the processes of stars and bring us closer to harnessing fusion power. The International Space Station is a turning point in both cooperation and human advancement for our quest into space. Space is full of space. Scientists have always been fascinated by what space is, or more importantly, what it's not, and what passes through it. From the 1960s, probes were being sent aloft, not to any specific target planet or moon, but to seemingly empty, between the planets, deep space. Pioneer 5 was sent to study the space between the orbits of Earth and Venus. Its scientific instruments aboard set to study transient particles, magnetic fields, and gamma rays, it found that space was far from empty. Over a 3-year period, 4 more Pioneer probes were sent aloft, dispersed around the Sun in deep space to make a detailed and comprehensive study of the Sun's effects on the solar system, solar winds, solar magnetic fields, and gamma rays. They also studied solar storms and how they affect communications on Earth. The Pioneer series concluded that to study deep space, one should look more closely at the center of the solar system, the Sun. Early in the 1970s, West Germany and NASA launched 2 probes, Helios 1 and 2, utilizing Air Force Titan launch vehicles. Their aim was to study the Sun, and they were launched into heliocentric orbits. In the process, they set a probe speed record of 252,792 kilometers per hour. They also set the record for the closest orbit to the Sun. Both probes sat in an elliptical orbit inside the orbit of the planet Mercury, with their closest approach within 45 million kilometers of the Sun's surface. Sent to study the solar processes up close, they had completed their mission by 1980, but continued to send data till the mid-80s.
Engine start, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Discovery and the Ulysses spacecraft bound for the polar regions of the Sun.
Ulysses was another joint venture between NASA and the European Space Agency. Launched October 1990 from the cargo bay of the shuttle Discovery, Ulysses was sent to investigate the Sun. Once deployed, a 2-stage solid rocket booster accelerated Ulysses towards Jupiter. A 3rd payload assist module boosted it even further and faster, and in so doing set a new speed record. To improve observation of the Sun, this probe was unique due to its planned orbit, perpendicular to the plane of the ecliptic. In other words, at 90 degrees to the Earth and most other satellite orbits. This type of orbit is rare due to the amount of energy required. Ulysses accomplished it by a slingshot flyby of Jupiter. Orbiting in this way, Ulysses would be able to investigate the entire surface area of the Sun, including the never-before-seen polar regions. Solar panels could not provide the necessary power for the 10 onboard experiment packages, therefore Ulysses was powered by a radioisotope thermoelectric generator. Ulysses reached Jupiter February 8, 1992, and performed its swing-by maneuver, the giant planet's gravity deflecting the tiny probe down on an 80.2-degree angle from the ecliptic plane. Ulysses was able to study both north and southern regions of the Sun as it orbited between 1994 and 1995. The mission was planned to end in July 2008, but is proceeding until it runs out of hydrazine fuel or the remaining fuel freezes, whichever comes first. Ulysses revealed some fascinating insights into the Sun's magnetic field, which flips every 11 years, or 1 solar cycle. A further series of robotic probes were launched to continue studying our solar environment. SOHO, or Solar Heliospheric Observatory, is another NASA and ESA collaborative effort to study not only the solar winds, but the Sun up close, from its outer corona to its core. Its close observation of the surface and Sun spots has led to numerous discoveries about how the Sun works. Together with Ulysses and SOHO, Cluster 2, another ESA project, is also looking at the Earth-Sun relationship. Cluster 2 is a group of 4 identical satellites flying in formation and operating in a special Sun-facing orbit. The Earth is protected from the full impact by its magnetic field, the magnetosphere. But these explosions can still generate storms that have a bearing on even our daily lives.
It's something that took 2 days to get to Earth, so it's traveling at nearly 1,000 kilometers per second. So it's very, very fast, but it's traveling a large distance. So it's hard to appreciate the distance and how small and insignificant the Earth is, with its huge thing coming towards us.
The SOHO spacecraft monitors the Sun itself and the magnetic field, while the 4 cluster satellites orbit the Earth, providing information on the direction of the solar explosion.
Currently, spacecraft are switched off during storms. So we have, within this building, we have people working in different fields in astrophysics. We have to switch off when a solar flare goes off, because it will damage the detectors. So we currently do actually respond to these things quite quickly, but there's a lot more that can be done for communication satellites.
Though such an explosion poses no direct threat to the Earth, its effect remains considerable.
The big step forward would be being able to predict exactly when one of these explosions was going to occur. And at the moment we can say that particular region in the sun looks like it's going to be very active, but we can't predict when you're going to get a really nasty storm.
SOHO has also broken the record for comet finds. To date, she has discovered, by accident, over 620 comets orbiting our sun. To maintain this extensive research of the sun, another probe was launched in 1997. ACE is also positioned at the forward Lagrange point facing the sun. It is providing constant weather reports on solar activity and the solar wind, looking out for the stormy conditions that disrupt communications and power on Earth. When an event occurs on the solar surface or a flare is detected, ACE can give up to 1 hour's warning of an impending disruption or radiation threat to astronauts in orbit. The spacecraft has sufficient reserves to operate until 2024. Indeed, scientific study had revealed that empty space is full of interesting plasma energies, particles, fields, and fluxes, not unlike the analogy of a fast-flowing river. Energy emitted from the sun moves outward through the solar system. The planets and moons orbiting create magnetic bow waves and trailing edges within this solar wind. Boundary layers between have interesting properties of their own. Cosmic and other radiation from outside the solar system causes other effects and influences. The entire solar system is also moving through space, forming a larger shock wave, boundary layers, trailing edges and vortices within the interstellar medium of space. Genesis was a deep space probe with a message in its tail. Genesis was the first attempt to collect a sample of solar wind and return it to Earth for study. The complex probe cost $264 million and was launched August 8, 2001 aboard a Delta II rocket. It traveled a very complicated trajectory through deep space, utilizing the Interplanetary Transport Network, a traversable low-energy network of gravitational tunnels about the solar system, to a special chaotic Lissajous halo orbit at the Earth's L1 Lagrange point. There, it exposed ultra-pure wafers of its collector array to pick up atoms of the solar wind. Firing its motors, the probe, with its tantalizing cargo secured aboard, began its long return trip back to Earth. September 8, 2004, and on a flyby of Earth, the Genesis probe dispatched its sample return capsule. After traveling those millions of kilometers through space, the capsule descended towards its appointed landing site in the southern desert of the United States. The probe's parachute failed to open, and it crashed into the ground, destroying the capsule and its contents. It was later found that an accelerometer that would have signaled to deploy the parachute had been installed backwards. Fortunately, some fragments were recovered and useful samples taken. But it also proved once again that immutable law of Murphy. In 2006, a pair of probes were launched. The two stereo spacecraft were slingshot around the moon in slightly differing orbits. One went forward ahead, the other fell back behind. Both in the same heliocentric orbit as Earth, but millions of kilometers apart, providing a truly stereoscopic view of the sun. This was to provide further observational details of the star's surface, and in particular, solar flares. The same year, Yoko, or Solar A, was replaced by Japan's second solar observatory, Solar B, dubbed Hinode, launched from Uchinura Space Center, September 23, 2006. The satellite had been a coordinated effort between Japan, the United Kingdom, and the US. The space vehicle contains a solar optical telescope with a 50-centimeter aperture, an X-ray telescope keyed for high temperatures in the 0.5 to 1 megakelvin range, and an extreme ultraviolet imaging spectrometer to look at the plasma fields in the corona and transitional region. Observations by all three telescopes simultaneously will help to understand the correlation between the magnetic structure and the dynamic processes in the corona, as well as the effects the plasma stream will have on the rest of the solar system.
We know now that the solar wind from the polar regions is fast. It's faster than what we'd seen before in the ecliptic, very often. Travels about 800 kilometers a second, whereas the speed that we normally see in the ecliptic is half that. And we found that this is really the normal solar wind. It fills much of the heliosphere over much of the solar cycle.
To help study the effects at long distances of the solar wind, plasma scientists turned again to the largest and most influential planet in our solar system, Jupiter, and her massive magnetosphere. The probe Galileo, that had previously studied 2 asteroids and witnessed the cometary strike on Jupiter, reached its final destination in December 1995. Galileo would become the first probe to orbit the Jovian world and first to deploy a probe into its broiling atmosphere. Its 2-year mission was to study Jupiter and its magnetosphere, which it accomplished by several large elliptical orbits about the planet, which also allowed the probe several close flybys of the larger Jovian moons. Once its main objectives had been reached, the probe's mission was extended in 1997 to fly much closer and more hazardous approaches to the 2 more interesting moons, Europa and Io. The probe reached as close as 180 kilometers. The study of Europa has scientists believing it may contain an ocean of water below the ice crust able to sustain life. Radiation levels near Io were hazardous to the probe, and it lost several sensors to radiation damage. Galileo was finally decommissioned in 2003 after 14 years of service. To avoid any possible earthly contamination of Europa, the probe was deliberately sent into Jupiter's atmosphere at 50 kilometers per second and destroyed. Cassini-Huygens was a probe sent further afield than Galileo, but with the same intent. Cassini was gunning for Saturn, and in particular the moon Titan. Unlike any other moon, Titan is shrouded in a thick atmosphere, its surface unseen. A joint NASA-ESA venture, NASA designed and developed the Cassini orbiter, and the Europeans developed the Huygens probe that would descend to Titan's surface. Launched October 1997, the vehicle reached Saturn July 2004.
The major objective of the probe mission is to measure all the properties of Titan's atmosphere and make sure that we understand the behavior of the atmosphere, and also make some remote sensing in terms of taking pictures of the surface itself.
On December 25th, the Huygens probe separated from the orbiter and began its journey to Titan. January 14, 2005, the probe entered Titan's atmosphere and descended to the surface, relaying scientific data and images. Titan is larger than Earth's moon and even the planet Mercury. Designed to aerobrake and then parachute down to the surface, the probe carried a complex analytical laboratory to study the atmosphere. On its 2.5-hour descent, it also took over 700 photos, half of which were lost due to a transmission failure. With the haunting radio waves emitted by Saturn as a background melody, the Huygens probe journeyed down, scanning and analyzing, measuring distances and pressures. The atmosphere is composed of nitrogen and includes clouds of methane and ethane. Titan has wind and rain and large bodies of liquid on the surface, all governed by a seasonal weather pattern. Huygens landed on solid ground, although it did photograph a beach beside a sea. Cassini radar imaging later confirmed the existence of these numerous lakes, possibly containing hydrocarbons. A world much colder than our own, but nonetheless one that may be able to harbor life. The Cassini orbiter continued its mission orbiting Saturn. Her primary tasks to study the structure, shape, and dynamics of Saturn's rings, the surface composition of her moons, to map and measure the planet's magnetosphere, and the effects the Sun's solar winds have in this region. Whilst studying the solar winds and plasma, an interesting observation was made of one of the major moons, Enceladus, which led to a fascinating discovery.
We saw in the magnetometer data body itself acting as an obstacle to the flow of plasma, and so something was stopping plasma from Saturn reaching down to the surface. And so we said to the project, we think there's an atmosphere there. Let's get closer and see.
A closer look was made at the moon on the following orbit, which discovered the moon had a partial atmosphere and the moon itself contained water.
It's a very exotic atmosphere. Usually when you think of an atmosphere, you think of one covering the entire body. What we are finding is that it's concentrated mainly at the South Pole. You have this large gas of water vapor coming off from the South Pole, and the water vapor is appearing to come from stripes, tiger stripes on the surface. These tiger stripes are linked to hot spots, and so the South Pole is extremely hot compared to the rest of the surface. And so what we think is happening is we've got venting of water vapor coming off from the South Pole.
Scientists had long thought that Enceladus was the source of Saturn's E ring.
At Enceladus, it's a very small body. It's 500 kilometers in diameter. We expected it to have cooled down from when it first formed. But the implication of what we're seeing is there's a heat source that's causing the ice on Enceladus to vaporize. And so something's heating up the ice and causing this water vapor to form, which is causing the South Polar Cloud.
In 2008, NASA extended the orbiter's mission a further 2 years. New Horizons is a spacecraft currently en route to the farthest reaches of the solar system. Launched 2006 directly into a solar escape trajectory, it broke all previous speed records, obtaining an Earth relative velocity of 16.26 kilometers per second when its booster engines shut down. Relative to the Sun, it was traveling at 17.18 kilometers per second. At that speed, it reached the vicinity of Jupiter in a little over 1 year's travel. After another year and a half, it had reached the orbit of Saturn on June 8, 2008. However, its mission lay much further and will not be reached until July 2015. Its goal to be the first probe to reach Pluto. Known as a dwarf planet, Pluto is suspected of being a cosmic gatecrasher, part of the Kuiper belt of objects on the outer edge of the solar system, and is no longer classed as the 9th planet of our solar system. Pluto does, however, have 3 moons of its own, all of which are to be studied by New Horizons: Charon, Nix, and Hydra. If all goes well, New Horizons will go on to study other regions of the Kuiper belt. And who knows what it may find there. There is no such thing as a Martian curse. Spaceflight is a hazardous undertaking. One must expect failure from time to time. What's that? How come nearly 50% of Martian probes fail, compared to the tiny percentage of failure of all other destinations combined? One New York journalist attributed it to the galactic ghoul that lived on a diet of Mars probes. Fantastical space creatures are easier to comprehend than the complexity of interplanetary travel and the millions of variables that go to make a successful mission. During the 1960s, the then USSR sent 8 probes towards Mars. None made it. The USA were a little luckier. 3 out of 4 flyby missions were successful. The 1970s were no kinder. USSR, 11 launches for a total of 6 failures and 1 incorrect orbit due to a lack of fuel. USA launched 4 probes, 1 failed completely, but 2, the Vikings, landed safely, June and July 1976. After no life signs were detected, interest in the small red planet began to wane. In the 80s, only 2 probes were sent to one of the moons, Phobos. 1 spacecraft was lost en route, the other made it to Mars orbit, then was gobbled up by the galactic ghoul. The 1990s and new technologies, improved materials, better programming, and robotics all led to a renewed interest in studying Mars. The history of the planet is considered very important to researchers. It may hold many answers for the future of Earth.
Our reason is mainly because it's the planet that's most likely to have been habitable in terms of supporting life of all the planets other than our own. And there are many analogs between Earth and Mars. The Martian day is very close to the Earth day. It's tilted on its axis, so it has 4 seasons. We believe Mars had liquid water at one time on its surface. We know liquid water is a very important element of supporting life here on Earth. But today Mars is very different from the Earth. What happened? Why did Mars end up that way? Did it support life? And what does it mean for the Earth?
Armed with miniaturized robotics, NASA launched Mars Observer 25th September 1992. The orbiter was designed to study the mineralogical composition of the surface, map the topography, and study the Martian magnetic field. Unfortunately, the galactic ghoul was peckish, and the probe was lost once entering Martian orbit. The Russian Federal Space Agency tried in November 1996, launching an orbiter and multiple landers with ground penetrators. Called Mars 96, the heaviest planetary probe launched to date, it managed to make it as far as Bolivia after a launch failure. That same year, NASA tried again. Mars Pathfinder was launched 4th of November. More a test project than just another probe, Pathfinder was smaller, smarter, and much cheaper than ever before. New techniques were being tried out: airbags for landing, autonomous object avoidance, and other refinements. The probe reached Mars 4th July 1997 and entered the thin Martian atmosphere. After air braking, a chute was deployed. The probe was then engulfed in a collection of self-inflating airbags before being released from the chute. The probe then impacted the surface, bounced and tumbled until coming to rest on the surface. The bags deflated, revealing an undamaged space vehicle. The probe had landed in a relatively safe place called Ares Vallis in the Chrysi Planitia region. After system checks, the probe then got down to business and opened its solar wings and extended ramps to release its small robotic crawler dubbed Sojourner. Sojourner was the highlight of Martian exploration to date. A remote-controlled rover with the ability to move autonomously and avoid obstacles, it relayed information and pictures back to the lander, which then relayed them to Earth. The rover gave scientists the ability to explore and sample rocks further afield than the traditional static probe. From July to September, the rover returned 550 images and 15 chemical analyses of rocks and soil. The lander continued to observe and record, as well as taking 16,500 photographs and making extensive analysis of the Martian weather. Their combined efforts have led scientists to believe that Mars was once warm and wet, with running water and a thicker atmosphere. Scientists next wanted to know why the environment has changed so much. The lander and rover outperformed their expected lifespans, but communications with the lander were lost, probably because the electronics could not stay warm enough during the Martian night. NASA was unable to re-establish contact, and mission closed March 10, 1998. Buoyed by this success, NASA also launched the Mars Global Surveyor November 1996. The orbiter probe traveled the 750 million kilometers to Mars and reached orbit September 11, 1997. Global Surveyor inserted itself into a near-perfect circular polar orbit at a height of 378 kilometers and orbited from pole to pole in 117.6 minutes. The probe could photograph the entire surface of the planet in 88 orbits, after which it would retrace its steps and, with subtle rotation and pitch maneuvers of the probe, produce high-definition images of the entire planet's topography. The probe was also able to take images of the two moons and even photograph other space vehicles. The craft also photographed two craters named Terra Sirenum and Centauri Montes, which looked like they had liquid water in them sometime between 1999 and 2001. The probe lost contact with Earth November 2006 after receiving instructions to adjust its solar panels to the Sun. A faint signal was received sometime later, indicating the probe had gone into a safe mode, possibly from the failure of its solar batteries. The galactic ghoul struck again in 1999 when the Mars Climate Orbiter attempted to enter Mars orbit. Apparently, someone forgot to change a navigation calculation from imperial to metric, and the craft dove into the planet's surface. Another probe launched 2 months later, but in conjunction with the Climate Orbiter, was the Mars Polar Lander. As the name implies, it was to soft land in the south polar region of Mars in search of water, and to study carbon dioxide and other weather elements. The main probe carried with it 2 other penetrator probes to explore the subsurface conditions. On entering the Martian atmosphere, contact was lost, and another score chalked up by the ghoul. The new millennium brought with it a renewed hope of a successful Mars season, beginning with the 2001 Mars Odyssey spacecraft. Launched April 7, 2001, the craft was named after the Stanley Kubrick science fiction movie 2001: A Space Odyssey. the craft took 6 months, 1 week to arrive at Mars and settle into orbit. The main objective was the search for water and any volcanic activity on the surface, utilizing images and spectrometers. The spacecraft had made orbit more easily than expected and retained far more maneuvering fuel, thus extending the craft's life expectancy. The orbiter was also a very effective relay station for later surface probes, and its mission has been extended by 2 years 3 times. Japan was the third nation to join the Mars Club. The Institute of Astronautical Science at the University of Tokyo designed and launched their very own spacecraft named Nozomi. It was designed to study the upper atmosphere, including the ionosphere of Mars. Flown into an Earth-parking orbit by an MV launch vehicle, the spacecraft went through a series of Moon-Earth flybys to build up velocity. The final swing-by, assisted by its own rocket engine, resulted in a leak of fuel and insufficient velocity to reach the required Martian orbit. Its heliocentric orbit brought it back past Earth, but a solar flare damaged its electronics and communications systems. It would seem the galactic ghoul had a fancy for sushi. The European Space Agency was the next to try. Mars Express, designed and built in Europe, would carry Beagle 2, a British-designed lander, to the Martian world. Launched June 2003, the space vehicle reached Mars December 25, 2003, a record short journey thanks to a 60,000-year orbital alignment between Earth and Mars, and one of the reasons for the spacecraft's name, Express. Its main purpose was to perform a mineralogical survey, radar subsurface mapping, and a study of the atmospheric circulation and interaction with space.
3.8 billion years ago, the surface of Mars had significant episodes of liquid water on its surface. But suddenly at that time, there was a big climate change on Mars. So water was no longer possible on its surface, and presumably it took refuge below the surface. This is what we are also trying to look with Mars Express, that allows us to look below the surface down to about 5 kilometers deep. And we have indeed identified some layers of water ice, not liquid. What do you saw?
The Beagle 2 was dispatched December 19th. Its purpose? To perform geochemical analysis and exobiological search for life. The lander made it to the surface before being gobbled up by the ghoul. NASA then had a string of successes that made the developers of small, low-cost autonomous robots proud. Launched June 10th and July 7th, 2003, 2 identical probes with autonomous rovers were dispatched to Mars. The rovers were named Spirit and Opportunity, and they found both in abundance.
You can't control the rovers in real time. You can't operate them like a remote-controlled car. So the rovers have to be smart enough to be able to carry out instructions on their own, not only to do what we tell it to do each day, but also to keep itself safe, because it's going to be in an unknown environment. These rovers are going to be traversing over rocks. There could be unlikely to be hazards. The rovers have to be smart enough to avoid those hazards, but still be able to carry out the commands that we send it each day.
Spirit landed, courtesy of the proven airbag delivery system, 4th January 2004. After extending its solar panels and after a health check, the rover set off at a stately 10 millimeters per second, although it has a top speed 5 times greater. Each 6-wheeled robot stands 1.5 meters tall, 2.3 meters wide, and 1.6 meters long, weighing 180 kilograms. Each wheel has its own electric motor and can operate on a steep incline up to 30 degrees. solar panels keep the ion lithium batteries charged, and an internal radioisotope heater keeps the electronics from cooling down too far in the minus 40-degree Martian nights. The two robots trundled about the landscape as directed to interesting-looking rocks or formations. There they would drill and photograph, conducting analysis, then moving on to the next objective. Throughout history, discoveries have often been made by accident. Mars is no exception. When one of the wheels of the robot failed, Mission Control had to just drag it along. It dug a deep furrow as it went, and when scientists looked back, they discovered that the broken wheel had dug up all sorts of amazing salts and minerals from under the red soil. More evidence of water. August 2005, and pushing their luck, NASA launched an Atlas V booster towards Mars. It carried another probe, the Mars Reconnaissance Orbiter. Designed to gather information over an entire Martian year and to study the climate changes and seasons in detail, it will also look for suitable landing sites for future missions. Its main sensors include a stereo imaging camera, an imaging spectrometer, and a shallow subsurface sounding radar. A Mars color imager will help track sandstorms. The orbiter reached Mars 10th March 2006. Over several months, the orbiter gently nestled into its correct orbit by a combination of thruster motors and aerobraking. There was no sign of the galactic ghoul. The Mars Reconnaissance Orbiter was another step up in planetary probes. It carried the most powerful telescopic camera yet deployed to another planet, instruments to study every layer of the atmosphere, and a powerful radar to search underground for minerals, water, and ice. The orbiter also carries a 3-meter communications dish and a powerful transmitter able to send more data than all previous probes combined. The main camera can define rocks on the surface of Mars as small as a desk. One main function will be the mapping of the entire planet and searching out the best possible landing sites for future probes and manned missions. The polar regions of Mars are by far the most interesting for scientists because they know there is both water and ice there. The prerequisites for both life and a supply source of water and air for any future human presence on the planet. Launched 4th August 2007, NASA's Phoenix was targeted towards the northern polar region of Mars for the specific purpose of studying the climate and weather interaction with the surface and the composition of the atmosphere so far north of the equator. Phoenix will also study the history of water on the surface and how it shaped the terrain and subsurface, where it still may support biological processes. After aerobraking in the atmosphere and deploying a chute, the lander made a powered descent to the Martian surface. Phoenix itself is an 8-sided base supported by 3 extendable legs. A steerable medium-gain dish antenna is its main communications tool. It can report back to Earth directly, or, as it has been doing, relaying messages via either the Mars Odyssey or the Mars Reconnaissance Orbiter. After landing, it waited a few moments for the dust to settle before 2 solar cells were deployed to provide electricity. After a quick self-test to make sure all was well, the probe then began operations, deploying stereoscopic cameras, meteorological sensors, and a robotic arm. The first order of duty was to take photos of itself and its surroundings. The main research tools are a microscopy electrochemistry conductivity analyzer, or MICA, surface stereo imager, thermal evolved gas analyzer, and the meteorological station. The main purpose of the robotic arm is to scoop up soil samples and deposit them in the MICA unit for analysis. There, the search for signs of biological functions commences. So far, evidence of mineral interactions with water has been verified. Another sensor, a laser beam, was fired into the atmosphere. It has detected snow falling from Martian clouds. Unfortunately, the snow vaporizes before it can reach the ground. The search for liquid water and the chemical processes for life goes on. With the battery of new high-tech sensors scouring the planet, it should not be long before both are found. In 2011, the ESA's Aurora and ExoMars project will be putting another mobile laboratory on the surface. This one will be drilling into the ground in search of water and signs of life.
The most important element of a rover is a drill. And this is because we believe that in order to address the scientific objectives of the mission, we have to look in the subsurface, underground. We're looking for organic molecules that we can either associate with processes that are important for cellular life, or we are looking also for residues, organic residues of possible life molecules.
A manned mission to Mars is not too far off, but for now we have to be content with robotic exploration. However, if one listens to people who have been out there, one may find some enlightening advice.
People who go in space need to have a good reason to do that, because it's very difficult, it's very costly in resources. And I think to justify the large expenditure of going to Mars with humans rather than robots, I think we must get the most out of our investment. And to me, that means that people who go to the surface of Mars go there to stay and settle as colonists, and they don't come back.
The space age began April 12, 1961, when Soviet Major Yuri A. Gagarin first orbited the Earth in his Vostok 1 spacecraft. He was promoted to colonel whilst mid-orbit on his 108-minute journey that took him to an altitude of 327 kilometers. Gagarin not only rode a modified intercontinental ballistic missile on his first and only spaceflight, but he rode into the history books as well. The Soviet Union had long been in serious competition with the United States over military and technological dominance of the world. In this one momentous achievement, the Soviets did both. Gagarin landed safely by parachute after ejecting from his capsule and walked into the status of national hero, a role reserved for courageous men who lead the way. The US panicked and quickly fired off 2 manned suborbital flights. Shepard and Grissom, however, were overshadowed by a second Soviet flight with the first orbital flight of John Glenn. Since 1962, many people have had the privilege of flying into space, but they have always been delivered there by either the Russians or the Americans. No other nation was willing to place a man into orbit or technically capable of doing so. The sheer financial cost alone to establish a space industry is prohibitive. Though many nations frequently launch their own satellites and probes, it's another level again to haul a human into space, which requires life support systems, re-entry craft, much heavier launch vehicles, and so on. But in 2003, after over 40 years, one nation decided to join the independent spacefaring club. China has a well-developed ballistic missile program, and with economic growth the envy of many nations, it decided to invest in this domestic manned space flight program. Their astronauts are called taikonauts, and their first was Yang Li-wei. Li-wei was born 21st June 1965 and became a fighter pilot, logging 1,350 hours in flight, achieving the rank of lieutenant colonel. In 1996, he was selected as an astronaut candidate, where he commenced his training and won selection only shortly before the flight. Strapped into his Shenzhou 5 capsule at the Jiuquan launch facility, he was sent aloft atop a Long March 2F rocket. The Long March 2F rocket has minor changes and safety improvements over the Long March 2E model, the Chinese satellite launch system from which it is taken. Standing 62 meters high and with a diameter of 3.35 meters, it's a 2-stage rocket and first flew November 1999. It has a 7-for-7 success rate to date. Yang reported unusual vibrations shortly after takeoff, describing the flight as very uncomfortable. Changes were quickly made to the subsequent launch vehicle's engine feed pipes and their harmonic frequency of vibration. Chinese public were glued to their TV sets or watched in public where large video screens were available. Astronauts and cosmonauts from around the world also watched with interest.
我经历回来非常好，ili po-ruski, как я могу. 我经历一路好。
I think it's a tremendous indication that human history is moving forward. And I do believe other nations will take note of what China has started to accomplish today. It's very significant for the world.
This first manned flight lasted 21 hours, 22 minutes and made 14 orbits of the Earth. In that time, Yang made regular updates as to his well-being and spoke to his wife and son. He also ate a meal of kung pao chicken, rice, and tea. During the journey, he waved the Chinese flag and the flag of the United Nations on television for the viewers. He even received a call from Chinese Premier Wen Jiabao. Like all previous heads of government of spacefaring nations, he too could make political points and look good rubbing shoulders with their space hero. The flight concluded and the descent capsule separated from the orbiting components of the Shenzhou spacecraft, which remained in orbit and descended for a parachute landing in Inner Mongolia, just kilometers from his planned touchdown point. The retrieval team reached him within a short time and dragged him from the capsule. Looking somewhat bewildered, he was held aloft, smothered with flowers, and manhandled about.
They're at the top table of technology and the sort of technological capabilities of nations as a result of doing this. I mean, it's certainly a sort of historic event, and the national pride really, I think, is the key reason they're actually doing it.
Like his counterparts before him, Gagarin and Glenn, Yang Liwei is a national hero in name and deed, the public cheering him all the way to the podium, and in China, that's a lot of cheering. No sooner had Liwei hit the ground than he and the Chinese nation were swept off their feet by space madness, not unlike America of the 1960s. And true to nature, the commercial potential was jumped upon by many businesses.
Well, China, I think, is just awakening to the promise of space. With the Chinese human space program, with the maturity of the Chinese aerospace program, then I think the consumer population, the mass market, has begun to wake up, and space is something that they can really experience. And obviously it's a global phenomenon, but China's a very important nation for us to be working with.
The Chinese, like their American counterparts, will soon be able to come one step closer to connecting with outer space. Space Services Incorporated, SSI, which operates out of the United States, launches rockets carrying customers' belongings into space, all for as little as $10 US. Space lovers will have the chance to mail a package all the way to the moon if they so desire.
I think it's the thrill of being part of a new frontier, the opportunity to really be a part of a mission, not to just watch it and not to just know that your country is doing it, but to actually say, I'm really a part of that. I'm involved in it. I think that's really the fundamental desire. And of course, space is intrinsically interesting to people.
In 1982, SSI, under the direction of Mercury 7 astronaut Deke Slayton, made history as the first private enterprise to launch a rocket into outer space, and has now decided to turn this success into an international business.
We are at the right time right now with the first successful launch with the low-cost rocket on April 28th. I think there will be a lot of Chinese people who would use our platform to send their wishes and photos and personal items to space, because it will be affordable.
The company says the success of the venture is thanks to a human fascination with the unknown, coupled with the perceived added value which items acquire from traveling into space. Items returned from extraterrestrial trips are often given to state leaders as gifts or find their way into an aerospace museum. China truly has joined the space age. The next stage of spaceworthiness is the multiple man launch and an EVA or spacewalk. Here, the Soviet Union pioneered ahead of the Americans the multi-man capsule, and cosmonaut Alexei Leonov, who on 18th March 1965 became the first human to walk in space.
5、4、3、2、1，点火！起飞！起飞！10:210标0分04秒988毫秒，10:210标0分04秒988毫秒。
So 2 years after their first launch, China conducted their second trial by fire. Shenzhou 6 was launched October 12, 2005. 2 astronauts this time, Fei Junlong and Nie Haisheng. They remained in orbit for 5 days, completing 75 orbits. Their mission was a complete success, 2 for 2. The third Chinese manned flight, Hsinchu 7, occurred 25th September 2008. This time 3 occupants, Zhai Zhigang, Liu Boming and Jing Haipeng. They also carried with them the Feitian spacesuit fashioned on the Russian Orlan M suit. A total of 6 astronauts committed to the training for this mission, the primary and 3 backup crew. Their training regimens were not unlike all other astronauts, floating in the big tank in spacesuits to simulate the weightless conditions of space. On 27 September 2008, they achieved the third and final stage of a spacefaring nation, the EVA. Zhai Zhigang exited the capsule and tied himself to the craft. There he floated about and waved a Chinese flag. The Hsinchu spacecraft closely resembles the Russian Soyuz, except it is much larger. It also features a powered autonomous orbital module that can remain in orbit even after the manned descent module has departed. But like Soyuz, Hsinchu has 3 main components or modules: the forward or orbital module, the central re-entry capsule, and the aft service module. This design allows for more living space than the US-designed spacecraft. What I want to know the most right now is whether you're in good health. I most of all want to know how your work is going. We are in very good health. Our space research mission is going according to plan. The spacewalk has been successfully completed. There's no need for President Hu and the people to worry. Indeed, there was little to worry about. The third manned mission was a complete success, 3 for 3. There does appear to be an Asian space race between China, Japan, and India. Not as fast-paced or heated as the US-Soviet race to the moon, but nonetheless a national rivalry does surface from time to time. The next cab off the planet looks likely to be India. They established their homegrown rocket program back in 1945, building up to a ballistic missile program in conjunction with nuclear weapons development. Their first spacefarer was squadron leader Rakesh Sharma. He flew aboard a Soyuz T-11 in 1984. They have also developed an advanced satellite launch capability. The ISRO, our Indian Space Research Organization, has also recently developed and launched a moon probe called Chandrayaan. The remote sensing lunar satellite weighed 1,380 kilograms at launch and carried high-resolution cameras for visible light, near-infrared, and soft and hard X-ray frequencies. It was mated to a Polar Satellite Launch Vehicle C-11. It's a four-stage solid and alternate-stage liquid-fueled rocket, the first solid rocket stage being the largest solid booster in the world, and weighs 138 tons. The lift capability of this vehicle is sufficient for placing satellites directly into either Earth geosynchronous or polar orbit or a sun synchronous orbit, a launch capability only most recently available commercially from the Russians. A C-11 launch vehicle recently lifted 10 satellites into orbit in one go with an 80% success rate. It is a very useful low-cost launch vehicle. The Chandrayaan probe and impactor were launched 22nd October 2008 from the Satish Dhawan Space Center about 80 kilometers north of Chennai.
Yes, the vehicle has lifted off. Vehicle has lifted off. Rocket उड़ान शुरू हुई. Ignition sequence normal and lift off normal. मोटर भी जलाई गई है.
The Chandrayaan flight profile was a continuously increasing apogee orbit from a low Earth perigee point, each orbit taking it closer towards the Moon. Eventually, the Moon's gravity captured the satellite, and it swung around under the lunar gravity and was captured into a lunar orbit. The probe was successfully orbiting the Moon 8th November 2008.
We have an onboard camera on the MIP, which is taking pictures of it. But these pictures are stored on board the Chandrayaan, and right now the Chandrayaan is behind the Moon. It will come out of the shadow after about an hour, and then we will be able to collect this data, analyze and bring out the pictures. Also, on this occasion, I would like to announce that our terrain mapping camera on board the Chandrayaan has been switched on, and beautiful images of the lunar surface to a resolution of something like 5 meters has been received. And they have 3 cameras which are looking at plus minus 25 degrees and nadir. With that, we will be able to reconstruct the stereo image of the lunar surface. The operation of a very vital instrument also has been proven today.
The probe carries 5 Indian scientific packages and an additional 6 from other countries, including NASA, ESA, and the Bulgarian Aerospace Agency.
Thank you very much. Sky majestically. Everything is good.
The Moon Impact probe detached from the main orbiter 14th November 2008 and made its way towards the lunar surface, the lander impacting in the southern polar region near the crater Shackleton. India is only the 4th country to place its flag on the lunar surface, and their plans to place Indian bootprints on the surface are well known. Although there are many corporations and companies jostling to launch their own space vehicles with paying customers aboard, there are really only 2 or 3 with the capability to succeed. The ease with which a commercial venture may collapse is high. Only populous nations have so far been willing to bear the brunt of the phenomenal costs. So the wager that the next manned flight to the Moon will be a non-state establishment is fairly high indeed.
Thank you very much for being with us, and this is an excellent mission that we have, a Texas mission, a perfect mission.
Dear colleagues and friends, it's a historic moment as far as India is concerned. We have started our journey to the Moon.
In recent times, ESA have demonstrated their Jules Verne unmanned autonomous docking capability with the International Space Station. They too have developed several manned spacecraft designs over the years, including Hermes. ESA have also designed the Clipper, a small space plane developed within the Russian Space Agency and a possible replacement for the Soyuz spacecraft. Like the US Space Shuttle, the Clipper would utilize a lifting body type design to glide back to Earth under its own control. However, the US will soon be retiring the shuttle fleet and replacing it with a throwback design similar to Apollo. It may be a warning to ESA that the advanced design spacecraft seem to have an unacceptably high failure rate. Japan, the third in the Asian space race, has had a keen eye on the Moon and Mars for quite some time, having access to manned flights via the shuttle fleet. They have been slow in developing their own manned capability, though they have done well with their robotic probes. In reality, any one of these nations could commit to a manned program and be well ahead of the game. It is certain that the next nation into space and further afield, perhaps even the Moon, will not have an American accent. Imagine Armstrong's famous words without the twang.
这是一个人迈的一小步，但是是人类文明的一大步。
The United States have NASA and the aging but very effective fleet of space shuttles to hoist their astronauts into space. They even have the Delta family of rockets to help out with the smaller spacebound cargo. The Russian Space Federation rely upon their time-proven Soyuz family of spacecraft to lift their cosmonauts into space. They can also rely upon their Proton rockets for less essential cargoes. Across in Europe, the European Space Agency have their family of Ariane launch vehicles to get to orbit and are planning manned capsules as well. Even China has its Long March rocket carrying the Shenzhou spacecraft. India has geosynchronous polar orbit and lunar capability.
Yes, the vehicle has lifted off. Vehicle has lifted off. Vehicle has lifted off.
And even Japan can lob a substantial space vehicle across the solar system. Whereas the rest of us, well, we have to put up with Many believe that the high and prohibitive costs of launching people and payloads into space are due to massive government bureaucracy, overstaffing, over-engineering, and a veiled attempt to corner the market. But some industry leaders and entrepreneurs see it differently. Many of these non-governmental groups believe they can do the same job, but more cheaply and more efficiently. And most believe the real way of expanding mankind into space is not just through scientific research and exploration, but industrialization and, above all, tourism. One such starting point was the X Prize competition.
We're investing competition money to get some really small companies going to try and see, okay, how can somebody else come up with some new technologies, new ideas to get back to the moon and help us explore further? And of course, we want to explore because we want to learn new things all the time.
Modeled on the aviation prizes of a century ago, the prize set a challenge to anyone who could meet a certain criterion. The reward, money, and fame. In those days, it was what prompted Lindbergh to cross the Atlantic. This X Prize was for a non-government group or industry that could launch a piloted vehicle to the edge of space, being defined as 100 kilometers altitude, return safely to Earth, then do it again within 2 weeks. Space tourism has been a reality for a select few with tens of millions of dollars to spare. But the truth is there are few with that sort of money, but many tens of thousands, if not more, people around the world who dream of leaving the bounds of Earth and experiencing space flight firsthand. These paying customers could very well be the backbone of future expansion into space.
What do I want out of this? Is it just the G-forces? Is it weightlessness? And my expression is, yeah, that's nice, but the biggest thing is looking out that window. That is it.
And to me, this is something that I spend every day thinking about, the excitement of doing it, just a thing that so few people have the chance to do.
Once the tourists get there, they will need to be trained, housed, fed, clothed, and even entertained. An entire new industry off-world. It would seem it is up to private enterprise and the entrepreneurship of a handful of people who are going to make this dream a reality. The idea for the X Prize was first put forward in 1995 at the International Space Development Conference by Dr. Peter Diamandis. The X Prize was created a year later. But it was in 2004 that its name changed to the Ansari X Prize after a multi-million-dollar prize injection by none other than Anousheh Ansari, an Iranian entrepreneur who had already been to space as a tourist on the International Space Station. She and her husband could see the value in promoting such a high-achieving goal.
I was offered the opportunity to go to train and learn more about their program, and just the idea of being with astronauts and cosmonauts for several months and learning from them was such a compelling idea for me that I couldn't say no. So in January 2006, I packed my bags and went to Moscow, Star City, to train as a backup for a Japanese businessman who was going to space. And about 3 weeks before the flight, I guess all the stars lined up for me, unfortunately not for him, and he failed one of his medical exams, and they offered me to fly in his place. And I remember the moment they told me the news, I was so excited that I just didn't even think twice that maybe I should talk to my husband, maybe I should ask someone. As soon as they said, "Do you want to take his place?" I said, "Of course, of course." Our planet Earth from space, you get a better appreciation and sense of how we are very, very, very tiny, minute part of something much bigger. It sort of reminds us to be humble and to understand our place in the entire universe. And at the same time, it gives you a better appreciation for our planet. Seeing it from up there, you can tell that it's a very unique place and a place that we all call home and we have to protect. Otherwise, you look around it and you know that if it wasn't there, there's not a lot of other places like it that you can just pack your stuff and go.
Ansari spent 11 days aboard the International Space Station. It was an experience that has changed her life and led her to invest her money to help drive the commercialization of space.
The freedom of floating in space and being able to see Earth is an experience that I think everyone ought to do, and I'm hoping that more and more people will be able to do it in the near future.
Now, the prize was not just the kudos of being the first private company to put a man in space, but the incentive of $10 million US as well. The competition got serious, and a total of 26 teams began designing and building their low-cost, reusable means of getting paying customers into space. Major aerospace companies like Lockheed and Boeing declined to enter the X Prize competition. Though they were eligible, they could not see how they could produce a cheaper space flight system than they were already supplying to the US government and others. Individuals and hobbyists, small aviation companies, larger interests with financial backing, all got involved in the X Prize. With 26 contenders in all from around the globe vying for the top honors, something strange happened. For the $10 million winning purse, a total of over $100 million was invested by these groups. It seemed kudos had value after all. But even that didn't account for the brilliance, dedication, and plain hard work put in by so many high achievers. Companies like Canadian Arrow, Armadillo Aerospace, and Bristol Space Planes Limited put in their designs, all viable projects. But there was a time element involved. Speed was of the essence, and that became the deciding factor. The winning design had to take a pilot to over 100 kilometers altitude, return, replenish or replace no more than 10% of the reusable spacecraft, and repeat the flight within 2 weeks. The prize was won on the 47th anniversary of Sputnik, October 4, 2004, by Scaled Composites and their Spaceship One. How it was done was a combination of several ideas. The flight itself was more like the flight path of the X-15 rocket plane of the 70s, air-launched from a mothercraft, the White Knight, which was also designed and built by Scaled Composites. The smaller suborbital plane nestles underneath the mothercraft as it is flown to launch altitude and released. Its hybrid rocket engine then fires. Rather than trying to obtain orbital speed, the rocket plane points straight up and aims to utilize the rocket engine's energy to obtain altitude only. When the engine shuts down, the upward velocity of the spacecraft takes it past the required 100-kilometer altitude to qualify for space. Then the craft changes its aerodynamic properties by feathering its wings and tail section. This increases the drag of the craft as it decelerates in the upward direction, giving the occupants a few minutes of weightlessness and a view of the Earth seen only by a few. In this stable configuration, the craft then begins to descend. Much like the flight of a shuttlecock, it falls gently down to a lower altitude, where the wings and tail return to their flight position, and the spacecraft glides back to Earth and a runway landing like the Space Shuttle, but for a fraction of the cost. Having won the X Prize and proven their design concept, developers Bert Rutan and philanthropist Paul Allen looked to further the idea, taking it to the next level.
And I feel a need to get our prestige as a business, as an industry, as a good old American capitalist, by working very hard to have a high volume manned space flight industry where there'll be a lot of flying and we'll beat the Russians again. Thank you.
It was my lifelong dream to find a way to participate in this next generation of space exploration. I saw Spaceship One as a great opportunity to demonstrate not just a proof of concept, but also demonstrate convincingly that private space exploration could someday be within the reach of private individuals.
Bert Rutan, who had designed and built Spaceship One and the White Knight mothercraft, was looking to go further than just suborbital flights.
My goal, and everybody, you know, when you get as old as I am and have all this gray hair and you get 60, you tend to think of, wow, what I'm going to do with the rest of my life. What would I like to see happen? What would I like to see occur? And I've got something pretty ambitious, and that is I do want to go to the moon in my lifetime. And I want to see affordable travel to the moon in my lifetime.
Even a brilliant designer like Rutan and billionaire Paul Allen still needed help to achieve their dream. They required someone brilliant in their own field who could push the project up over the next hurdle. And they found that someone in billionaire entrepreneur and businessman Sir Richard Branson. Richard Branson, keen adventurer, particularly in flight, founder of the Virgin Airline Group, and a man with a flair for theatrics, was the perfect match. To develop a commercially viable space flight tourist industry requires some ingenuity, not only on the part of the spacecraft engineers, but the tourism operators, and above all the financial source willing to spend the money in pursuit of the dream.
With the end of the oil era approaching and climate change progressing faster than most models have been predicting, the utilization of space is essential not only for communications, but also for the logistics of survival through things such as weather satellites, agricultural monitoring, GPS, and climate science.
Wasting no time, Branson signed on with Rutan, set up the Virgin Galactic Company, and commissioned the building of Spaceship Two, the next generation of spacecraft. Well, 5 of them actually. What are entrepreneurs for, anyway? With his knowledge and experience in promotion, and building and managing an international airline, he had the project up and running by the time it took to get to low Earth orbit. First task was to run a competition. For the winner, a free flight to space.
You know, you look up at the stars and think one day, and here the day has come that, a common person can fly into space.
Now came the not-so-common job of getting him into space.
Burt Rutan's prototype, Spaceship One, worked. So that hurdle was crossed. That was one of the big hurdles. Designing Spaceship Two has been relatively easy. We've had a lot of input from potential customers, so we've been able to design on the basis of what people want. And the most important thing that people want is to have a lot of space so they can move around weightless in the cabin and experience not only seeing the Earth, seeing the biosphere, the curvature, the atmosphere, seeing space, but also move around.
With a speed that would put even the Cold War Soviet space engineers and NASA to shame, an entire spaceflight system was designed and built by this small Mojave company in a little over 4 years. In 2009, the second-generation mothercraft White Knight II was launched. This unique dual-body aircraft will not only lift the Virgin spacecraft to launch altitude, but it will also serve for training passengers in a weightless environment. With all going well, the first commercial flights should commence in 2011.
Well, it's a dream that I've had, since I was a child. The idea of, one day going into space. To actually be building 5 spaceships, I have to pinch myself sometime when I wake up in the morning. And in 2.5 years' time, we'll be taking people into space. And we will be giving people, I think, the experience of a lifetime. And my ultimate dream is that in time we'll be able to bring the prices down and down and down, so that literally, millions of people will have the chance to experience space.
After separation, Spaceship Two will fire its hybrid rocket and climb some 100 kilometers above Earth, the internationally recognized boundary of space. The spaceflight, up and back down without circling the Earth, will include about 5 minutes of weightlessness. The total trip from White Knight II's takeoff to Spaceship Two's unpowered landing will last about 2.5 hours. And by all accounts, it seems there will be no shortage of willing customers.
We have 200 people who have committed to fly. And that's quite something, considering that we haven't actually unveiled the real spaceship yet, and we certainly know that more people will be signing up after they see the spaceship as well. Planning to fly 500 people in the first year of operations and 50,000 in the next 10 years. And what our real aim is to try and bring space travel to everyone, so that everyone has that opportunity, not just a few highly trained astronauts.
The development of the flight system is progressing well. Test flights of the mothercraft continue, and soon the spacecraft itself will be put through over 100 test flights before opening the doors to paying customers. Although there are still some who are a little nervous about the idea.
Safety is an issue, but that's more of a perceived issue than anything else. You have to at least make it as safe as possible. It's not going to be as safe as catching an airliner in the first phase, but then 50 years ago, catching an airliner was not as safe as it is today.
There is little doubt that the first few flights of Burt Rutan's Spaceship One have kick-started a new race to space. From the original X-Prize competitors, some have continued their development. Canadian Arrow have tested rocket engines and have recruited astronauts for their suborbital flight program. Other space companies like SpaceX are now being awarded contracts to put payloads into space for NASA and other commercial entities. However, as yet, they have not taken the manned flight route. None of these businesses have neglected to see the potential for expansion into other services within the space tourism envelope. Once again, Virgin Galactic leads the way. Having taken several full payments for seats aboard Spaceship Two, they are already providing the necessary training for each passenger. As part of the full space experience, fellow travelers get G-tolerance training at the centrifuge simulator at the National Aerospace Training and Research Center in Pennsylvania. They then undertake a zero-G flight in a specially designed aircraft at the Kennedy Space Center, Florida. The training is aimed at making the space tourists familiar with the fluctuations and changes in gravity that occur while entering space and re-entering the atmosphere. The facilities used for the space tourists are similar to those generally used for training the NASA astronauts. There are also the spin-offs of space travel development.
We hope to be able to start a program where we can try to fly people incredibly quickly around the world, from New York to Australia in less than 2 hours, and London to LA in less than 2 hours. I mean, that's the ultimate aim, and it hopefully will happen in my lifetime. We'll see.
Several companies have been hard at work with hypersonic flight. Australian, Japanese, and American development may be spurred on by this suborbital space race. Scramjet technology is the leading edge in atmospheric engine development, based on the same concept as the ramjet, where air enters the jet engine so fast it does not require turbines and blades to compress it to a usable pressure. The supersonic combustion ramjet, or scramjet, is seen as a possible low-cost method of reaching low Earth orbit or high-speed intercontinental transportation. Unlike rocket engines that need to carry oxidizer as well as fuel to burn, the scramjet gets its oxygen from the very thin upper atmosphere. Operating at speeds beginning at Mach 5, they can achieve near-orbital speeds. NASA has been testing this technology for some time. The difficulty has been that there is no wind tunnel available to generate the airspeeds necessary for testing surface designs, aerodynamic, and other properties. They have had to utilize B-52 drops and Pegasus rocket acceleration just to test the most basic components of their X-43 vehicle. The design for hypersonic flight is becoming better understood. This new method of propulsion is gaining headway, and with the commercialization of space by businesses and industries able to see the obvious benefits, the technology will be sped up. For nothing inspires research like funding. All going well, Virgin Galactic Spaceship Two will begin the ascent of the general public into space. They predict that their next generation Spaceship 3 will be an orbital vehicle capable of extended flights around the Earth. Perhaps Richard Branson's dream of flying from Sydney, Australia to London, England in 2 hours will very soon become a possibility. Oh, of course, that would include a stop-off for lunch and a spot of duty-free shopping at an orbiting low-Earth space station. The American Space Shuttle is the most advanced and complex machine ever flown. The remaining shuttles have served out their working life and are due for retirement after 30 years of service. What will replace it? What next to ferry payloads and astronauts to the International Space Station? The European Space Agency has its autonomous Jules Verne, an unmanned self-docking capsule to send supplies to the station. It recently underwent final trials and completed an autonomous docking with the space station, proving its capability.
and after 2 trial approaches, it automatically and gracefully latched onto the ISS docking port on the 3rd of April. Neither the astronauts on board the station nor the mission control teams in Toulouse had to intervene.
Over the weeks, the dozens of white container bags were transferred from the ATV's pressurized cabin to the ISS. Its empty racks and tanks were then used to store the station's dry and liquid waste and excess materials, some 2.5 tons stored into the cabin. It is automatically undocked and sent on its way, hurtling through the atmosphere to be destroyed along with the garbage in a fiery shower. Its mission ended. NASA has contracts pending with other companies, including SpaceX, to supply the necessary hardware to help maintain and supply the space station. Their capsule, the Dragon, now under development, is slated for operations in the very near future. A conventional blunt-nose, cone-shaped design, it will be launched atop their Falcon 9 launch vehicle. The Dragon capsule comes in 2 variants, the cargo only and the Dragon Crew, taking up to 7 crew or a mix of crew and supplies. Designed only for low Earth orbit, the Falcon-Dragon combination could be a low-cost answer to the continuous resupply and crew rotation to the International Space Station.
All systems are go for final approach.
Dragon is on final approach.
Even the Russians are looking past their 40-year-old Soyuz design. It's small and only carries 3 passengers.
The spacecraft is basically a concept from the 60s, and it's getting rather old, and it's also getting rather difficult to produce this type of spacecraft. Therefore, also on the Russian side, we are looking to a new generation type of spacecraft, which is called Clipper.
Clipper is the brainchild of Russian company RKK Energia. They previously built Buran, a Russian shuttle whose development was interrupted through lack of money. A life-size prototype has already been built. Clipper is a new generation of spacecraft. In designing it, we used some of the latest ideas. Since the construction of the shuttle and a former Soviet model, the Buran, a lot of new materials and new technologies have been discovered. We will use up-to-date Russian science in this new spacecraft, and we are ready to use all the European technology we can in the design of Clipper. The Clipper should be ready for liftoff by 2011. It will transport 6 astronauts into orbit and carry 500 kilos, or 2 astronauts and 700 kilos of materials. It's anticipated to start ferrying payloads to the International Space Station by 2012. The Clipper is a slightly unusual design snub-winged lifting body, with its docking adapter positioned to the rear. There are 2 options for landing, either by parachute in the Russian steppes, or a more conventional way, like an aircraft, if it takes place closer to a populated area.
The aim of Clipper is, of course, not just to bring humans to space. It's also not just the aim to go and serve the International Space Station, but the aim of Clipper is really also in the long term, 20, 30, 40 years from now, to be able to participate in human exploration of our solar system.
Developers also suggest that it could be used to ferry astronauts between an Earth and lunar orbit, where it would transfer passengers to a European lunar landing craft. In part a replacement for the shuttle and part a return to manned lunar flights, NASA have embarked on a project Constellation, which consists of 2 types of booster rocket, a capsule, an orbit escape booster and a lunar lander. The Ares 5 booster is the heavy lift component of the program, unmanned and consisting of a main booster with 5 RS-68 engines, a much larger and more simplified hydrogen-oxygen burning engine than the shuttle main engines, and 2 strap-on solid rocket boosters similar to the Space Shuttle. The second stage is the Earth Departure Booster, which will fly itself and the Altair lunar lander into a parking low Earth orbit, the main booster returning to Earth via parachute. The second booster is the manned Ares 1, consisting of a first solid rocket stage similar to the shuttle SRB, with a second stage liquid-fueled J2X Apollo-type era rocket engine. It will lift the new Orion spacecraft into low Earth orbit, where it will rendezvous and dock with the Altair and continue its journey to the Moon and later further afield. The Orion is an upscaled version of the Apollo spacecraft and will take from 4 to 6 crew members. It will again consist of a command module for the crew and a service module that will house propellant consumables and main engine. Orion differs from Apollo in that it will be reusable up to 10 launches and will utilize solar panels as part of its power system. It may also be able to land with the aid of chutes and airbags on terra firma, reducing the large cost of an ocean recovery. The Block 1 design will be for low Earth orbit operations to the ISS, Block 2 and 3 versions for lunar and deep space missions. NASA's return to the simpler system than a more advanced space plane was in part purely statistical. Apollo hardware had a 100% success rate, the shuttle a poor 50%. NASA's plan to return to the Moon in the next 10 years requires the 2 boosters, which would deliver the Altair lander, Orion manned capsule and Earth departure stage to low orbit, where they will dock and then utilize the EDS to gain the velocity for a trans-lunar journey. There the crew will transfer to Altair, undock in lunar orbit and land on the Moon. The planned Altair lunar lander will be able to carry 4 passengers from orbit to the Moon and back. Much larger than the Apollo-era lunar module, Altair will be designed to allow long stays on the lunar surface, including an airlock and a toilet. NASA is planning for a permanent outpost similar to the mission style of the International Space Station between 2019 and 2024. This will enable scientists to work for extended times on the surface, where there is still a lot of science to be done.
When the Apollo astronauts went to the Moon, they brought back a load of samples, and people thought at the time that that told you most of what you needed to know about the Moon. Over the intervening time, people have realized that there's a tremendous amount we still don't know about the Moon. For example, we don't know if the Moon and the Earth came from the same place. The way to find that out is to measure the composition of the whole Moon, and that's what DKICS, our little experiment, is going to do.
Numerous probes from several nations are currently in lunar orbit, making extensive and detailed surveys of the surface to aid in this science. One decision is which location would be best suited for a manned outpost. One high-potential site is on the rim of the Shackleton crater near the southern pole. It would take advantage of the extensive sunlight for power production and may also be near a supply of water, which the Indian Chandrayaan probe and NASA's Lunar Reconnaissance Orbiter will help to locate. The current outpost design consists of habitation modules, solar power unit, unpressurized rovers, an in-situ resource utilization unit, and a surface mobility carrier. Using the Altair lander and perhaps the ESA equivalent, an incremental build-up could begin with 4-man crews and cargo landers making short 7-day visits, working towards a 180-day stay. An early priority would be to learn how to use the local resources.
The problem on the Moon is there is no free oxygen in the air, and the US require oxygen to power their rockets from the Moon. And to take oxygen from the Earth to the Moon costs about £2 million per tonne, which is very expensive. For us to create a process on the Moon which will create oxygen from the rocks should make that very, very much cheaper.
To be able to manufacture oxygen and fuel directly from lunar regolith would be a major cost saving and enable stockpiles of fuel to be stored on the Moon, ready for use for later missions to Mars and beyond. Another key to lunar exploration is transportation, being able to traverse the rugged lunar terrain. Apollo astronauts had the lunar buggy, one of the most costly 4-wheeled devices ever built, but it served them well, allowing extensive forays away from their lander to collect a wide variety of mineralogical samples. NASA has a new design ready in the wings. The Lunar Electric Rover is a prototype vehicle that will allow astronauts to conduct research for up to 14 days. It includes 12 separate wheels, a bubble window in the front for close viewing of the surface, and a toilet. In order for astronauts to remain on the surface for that long, they will need to be able to both exercise and relax when they're not on duty, according to engineer Mike Gernhardt, himself a 4-time shuttle astronaut.
It's 10 cubic meters in volume. You see the central aisle here. It's tall enough for a tall person such as myself. I'm 6'2.5" to easily walk up and down the aisles. On the sides we have these bunks or benches, and the seats actually fold down to form a bunk or like a recliner. For example, at the end of a long day, you can sit back. We're going to have a TV monitor here. You can do your email, fill out your forms. It's very comfortable. When we see a sample we want to collect, we can quickly come back here. The suits are already checked out and powered up. We open this hatch, and we open the backpack or back hatch of the suit, and there is the spacesuit. So you literally, using these handholds, step into the suit. Once you're in there, there's a lever outside that will close the back hatch.
The rover's 6 pairs of wheels can be moved in unison or separately, the latter known as crabbing. The vehicle has a top speed of approximately 15 kilometers an hour. NASA believe this type of vehicle is a significant improvement on the old lunar buggy. Unlike the last lunar missions, the US will not be alone. This time, other nations will be joining in the return.
The space scene has changed quite dramatically over the last 2 or 3 decades. We have Europe now through ESA as a very significant player, and countries such as China, India, Japan, all developing very, very fast with very significant capabilities in space science, space technology, and the application. So it makes the situation a lot more interesting now. Very, very challenging, but interesting.
The ESA, Russia, Japan, China, and India are all looking to manned and robotic missions to the moon, and also building permanent or semi-permanent bases, most by 2035. JAXA is planning a lunar landing around 2020 and a manned base within 10 years of that. China has commenced a lunar exploration program seeking out minerals with the prospect of extensive mining of resources including iron and helium-3.
Working together is a key part of what we've been doing. We've been working with 14 different national space agencies throughout this past year to try to define our common interest in why go back to the moon. What do we all want to accomplish in exploration? So exploration as a unified endeavor between nations is definitely a key this time.
The spirit of the International Space Station seems to have rubbed off, with nations choosing to work closely together for a common goal.
We are trying to play a key role since the beginning, because what we are supporting is mainly to have this consultation process also with other space agencies like JAXA, the Japanese one, with Russia, with China, and with the United States. So this process will bring us to the definition of global strategy and a global open architecture in order to be able to fit in, to jump in with the European program at the end.
So for us, we love the challenge of someday going to Mars and sending people to Mars. But we see the realistic goal of we need to learn more technologically, we need to learn more scientifically. And so the moon provides us with a closer by neighbor where we can start learning more operationally, technologically to prepare. So that's a lot of why we're going back.
There are so many questions that we can address by going to the moon and Mars. I think we must go to them both. It's not one or the other. The moon, despite what some people say, you know, they say we've been there, we've done it, that's just not true. What we did at the moon in the Apollo era was good, but it was actually quite superficial. We've now got to go back, do detailed studies. We now realize fully that one of the benefits of the moon being actually a relatively inert place is that it has preserved a record of essentially the history of the solar system in the surface, in the rocks.
Mars is the ultimate goal for this generation of space exploration. How and when we send a manned mission is still up for debate. NASA have a tentative timetable for around 2030.
Mars, well, of course, for a long time, Mars has been regarded as the best bet for possible existence, past or even present, of life elsewhere in the solar system.
As sure as it rains, Someone will be taking that giant leap towards Mars. The question now might be what emblem is stitched on their armband. Hopefully, by then, it won't matter. With Mars beckoning our astronauts and scientists, the technical difficulties in getting a man there are still daunting. But traveling to the Red Planet is only half the challenge. Staying there is the other half. With so much still unknown about the mysterious small planet, further robotic study is required. NASA is planning an adventurous rover dubbed the Mars Science Laboratory rover, which should, all being well, reach Mars in 2012. The autonomous rover will be arriving in style with a new technique. First, the usual aerobraking entry into the atmosphere and main chute deployment and jettison of the heat shield. Then the upright rover will be hoisted down on cables from the re-entry capsule. Once touching down, the rover will be cut loose and sent on its way. The advanced rover will be the largest sent to another planet, and with a plutonium decay radioisotope power supply, it should operate for an entire Martian year, or 687 Earth days. It will carry on board the most advanced science laboratory to date. Its analysis ability will be second to none, with a suite of 5 tools at the end of its arm. 2 are contact or in situ instruments, 1 a spectrograph and a lens imager. It will be able to drill into rock and extract samples. Its primary goal is to locate and identify organic carbon compound. A high-power laser will vaporize tiny pieces of rock from up to 7 meters away, generating a tiny blast of plasma. Spectral analysis of the escaping gases with 2 specialized cameras will analyze the rock surface composition. The rover will scour the terrain and go where directed to take samples. With speeds of up to 30 meters per hour, this rover can maneuver autonomously and avoid dangerous terrain, although it does have a clearance of over 75 centimeters. The rover is designed for long-term survivability, including 2 central computers. One will remain dormant unless the primary computer fails. It will also maintain its own health, monitoring all systems and taking action if necessary to keep itself alive. It will have 10 so-called eyes, 6 engineering cameras for navigation and obstacle avoidance, including a pair of stereoscopic eyes for depth perception, and 4 cameras for scientific investigation. Like previous probes and roving probes on Mars, this one will also be looking for specific signs of life. Within its body is an extensive chemical analysis suite which will receive samples of soil, rock and atmosphere and investigate them for signs of life with 3 main tools: the quadruple mass spectrometer, gas chromatograph and tunable laser spectrometer. The 3 subsystems include the chemical separation and processing lab, the sample manipulation system, which will deliver samples for heating up to 1000 degrees, and the wide-range pumps to purge the various sample systems. It is expected that this big brother of the Spirit and Opportunity rovers will continue the groundbreaking scientific work of the 2 earlier probes and establish once and for all the existence of traces of life, either long dead or dormant, on the planet. Looking further ahead to 2020, ESA and NASA are developing a sample return mission. The complex mission calls for 5 spacecraft: an Earth-Mars transfer stage, a Mars orbiter, a descent module, a Mars ascent module, and an Earth re-entry vehicle. With their proven autonomous maneuvering and docking capability, ESA are planning to land the probe on the Martian surface, where it will drill into the ground and extract samples. Once sealed in containers, these valuable samples would be delivered to the ascent stage of the probe and secured, then rocketed back into orbit for a rendezvous in orbit with the Earth return vehicle. The samples would then be returned in a ballistic flight path back to Earth, where the probe would be secured and isolated for scientific analysis. Every precaution will be taken to ensure no Earth-borne contamination of Mars will occur and vice versa. No Martian microbial life, if it exists, could contaminate the Earth. With the experience gained from returning to the Moon and the ever-increasing knowledge base of the Mars environment, the expected arrival of humans on Mars will be a great technological achievement. But more importantly, the first steps to colonization of the solar system, something the human race is destined to do. The journey into space beyond the Earth and out of the solar system is only worth it if we can find somewhere to go, i.e., other worlds. The search for planets outside our own solar system has until recently been a very difficult undertaking. Astronomers had long theorized the existence of planets around other stars, but it was not until the mid-19th century that they began any scientific investigation. Detecting a small dark body orbiting a distant star directly was in fact considered impossible. However, indirect observation is possible. The earliest method was through astrometry, the accurate measurement of a star's position. Over time, a star may wobble. This wobble could be caused by something unseen, large enough and orbiting close enough to affect the position of a star, possibly a planet. They soon worked out the size or mass and distance such an object would have to be to cause such an effect. There is also microlensing. When a star shines light into space, the light rays will generally travel in a perfectly straight line, but not always. If some of the rays pass close to a massive object like another star, they will be bent inward by the object's gravitational field. In effect, the field will concentrate the light like a cosmic magnifying glass. So astronomers call this phenomenon a gravitational lens. Astronomers call it a microlens when the effect is created by a very dim object that wanders in front of a distant star and focuses the light just enough to make the star seem a bit brighter. This makes microlensing a powerful tool for detecting objects that would otherwise be lost in the vastness of space.
And the way planets are discovered in microlensing is that if a star has a planet, then and it's in a microlensing event, then the star is bending the light from a background star, from the so-called source. And if that light goes by the planet of the foreground star, the foreground planet can perturb the light curve, giving an extra little bump, or sometimes a big bump. And from those bumps, we infer the presence of planets.
Sometimes astronomers can even tell by the changes in brightness that the small, dim object has a smaller, dimmer companion, a planet. To date, 347 planets have been discovered, 20 with multiple planetary systems. The first multiple to be detected was orbiting Upsilon Andromedae. Until recently, all known exoplanets have been discovered by ground-based observatories. However, better results could be obtained from instruments in orbit. The most obvious telescope to use is Hubble, and it has helped confirm several planetary discoveries. There is also MOST, a microsatellite telescope launched by the Canadians to study tiny variations in light from stars. and Corot, launched into orbit by the French Space Agency. Corot stands for Convection, Rotation and Planetary Transits. Its primary task to seek out extrasolar planets with short orbital periods, Earth-like terrestrial planets. To date, Corot has discovered planets in 7 star systems. Then there is the massive Kepler telescope, a purpose-built space-based telescope designed to find terrestrial or Earth-like planets. Launched by NASA early in 2009, Kepler has been calibrating its sensors and has begun searching in the Cygnus region of the sky. The 3.5-year mission is designed to study 100,000 stars that are suspected of being home to planetary systems. Kepler weighs over 1,039 kilograms and is in position in an Earth-trailing heliocentric orbit. It is basically a Schmidt-type telescope with a 0.95-meter wide primary mirror with a 12-degree field of view. The heart of the device is 42 CCD chips, each 2200 by 1024 pixels. It has virtually no moving parts. Once the protective lens cap is jettisoned, it has just 3 mirror-adjusting mechanisms to help focus the telescope. To search for terrestrial planets from half to twice the size of Earth in or near the habitable zone of stars, Kepler utilizes the transit method of detection. When a planet passes in front of a star as viewed from Earth, the event is called a transit. Kepler looks for the tiny drop in starlight as the planet transits the star. Kepler focuses on each location for some 30 minutes, gathering the light from the faint star, processing the pixels and storing the data. Then, every so often, it will radio the data back to Earth for further analysis. Once detected, the planet's orbit is calculated, its mass and size worked out. Depending on the size and type of star, the type of planet can also be deduced. The current search area, Cygnus, is further in towards the center of the galactic spiral and contains numerous features, including the Northern Cross and the stars Deneb and Albireo. Kepler is most interested in planets that orbit in the habitable zone of stars. This zone is the region in space surrounding a particular type of star that would permit liquid water to exist on a planet's surface, one of the prerequisites for carbon-based life. Differing star types have differing habitable zones. If it's a terrestrial planet around a stable mid-sequence star and orbiting at a distance within the habitation zone, then it is a candidate for either having life or being able to sustain life. Perhaps, in the distant future, a colony? By all accounts, to date, it appears that Earth-like planets are quite common around main sequence stars like our own. The elusive signs of life are still to be found, but we have several likely candidates. Mars may have microbial life living deep underground. The moon Titan may accommodate some form of floral life. The clouds of Jupiter and Saturn may hold exotic floating life forms, and the water beneath the ice of Ganymede may be home to an entire planetary ecosystem. To find life amongst the stars, we must also search for life close to home. The question, is there life out there, has been asked for millennia. The answer will be a resounding yes. It's just a matter of time. Yet there is still a bigger question to be answered in the depths of outer space. There is the matter of matter, or not enough of it. From the observable universe, our mathematics and theories do not line up. There is not enough known matter in the universe to make it the way it is. There seems to be dark matter and dark energy that we know very little about.
This is the matter that we cannot see. 90% of the mass in the galaxy is invisible. We don't know where it is, we don't know what it's made out of. It's very difficult to see, but we do know it's everywhere. We can see its influence. To try and understand what that matter is and how it's distributed is fundamentally important.
Launched together, Herschel and Planck are two new deep space probes that will hopefully help answer this question. They are destined to orbit behind the Earth some 1.5 million kilometers away, hidden from the Sun, because these two telescopes require very cold conditions to operate in. The Herschel Space Observatory has the largest mirror ever flown into space and is designed to study parts of the wavelength spectrum seldom studied before. It is ideally placed to locate water molecules anywhere in the universe. The Far Infrared and Sub-Millimeter Telescope operates at temperatures close to absolute zero. It is cooled by a supply of liquid helium and therefore has a limited life expectancy. Its primary task is to study the birth and death of stars and the dust clouds surrounding stars that form planets. Planck is to look at the oldest forms of radiation left over from the first light of the universe, the infrared radiation emitted from the Big Bang. It will scan for the cosmic microwave background radiation over the entire sky, and with greater instrument sensitivity than previously launched, give us a highly detailed picture of the structure of the universe. Planck will, in theory, be sensitive enough to look back to the earliest possible observable time at the beginning of the universe. There, it is hoped it can shed light on the mysterious dark matter and energy that so puzzle the world's scientists and astronomers.
Now, if you look out into space today, you have stars and galaxies and clusters of galaxies. It's not uniform at all. How could the universe go from being so uniform to so not uniform as what we observe the universe to be today? And how did the universe come to be what it is today? This is really the basis of many astronomical observatories. But here, Herschel has a very good contribution to give in the question on the history of galaxy evolution. When did which type of galaxies form, and how did these big structures in the universe evolve? Because galaxies do not live alone, they live in clusters. And clusters of galaxies live in big clusters of galaxies. And today, we know that this whole fabric of where galaxies are and where they not are is like a sponge. And astronomers talk about structure formation in the universe. How did the universe get its large-scale structure that we can see today?
Answers to these questions will help scientists understand the universe so much more that they will be able to ask the next question and the one after that. In the meantime, scientists and research organizations continue their work closer to home. Many deep space missions are currently in transit and will not reach their goals until the next decade. Probes to Pluto and the Kuiper Belt, others to the solar system's boundary edge. Some probes are hunting down comets and asteroids, others peering into the sun. More space probes are being readied for launch to Mercury and Mars. A return to the Jovian giants and Titan is well underway. Looking to the end of the next decade, yet more plans are underway for probes like Plato. Plato will be a very wide photometric telescope sent into deep space. It will study a group of exosolar systems to better understand solar system formation. Seacoast, a chronographic telescope, will try to directly observe the reflected light from the larger exoplanets. A 3-spacecraft formation interferometry mission, Pégase, will study the giant Jupiter-type planets. This will be a lead-up to the major Darwin Deep Space Interferometer mission. Consisting of 5 spacecraft flying in formation, Darwin will collect infrared and spectral information on chemicals, namely looking for water, carbon dioxide and ozone, the basics for life, and indicators for life deep within the universe. The Earth will not be neglected either. A series of new orbiting satellites are to be launched soon to study the climatic changes in the oceans and on land. Several satellites are being prepared to monitor very closely the carbon dioxide and other greenhouse gases in the atmosphere and chart our progress in reducing these gases. Recently launched is the Themis group of satellites orbiting in the trailing edge of the Earth-Sun magnetic interaction. These probes have confirmed theories about a magnetic link between the Sun and the Earth's upper atmosphere. Magnetic ropes, as they are called, are field-aligned currents of electricity. Similar to a 30 kilovolt battery in space, the flux rope pumps a 650,000 ampere current into the Arctic. This project has also determined that one triggering event for solar substorms was the reconnection of this magnetic link every so often to the upper atmosphere, which also leads to intensified auroral activity over the polar regions. We are perhaps more closely linked to the Sun than we first thought. As this series has recounted, the history of man's journey off this planet into space has been a relatively quick succession of technology. Born out of war, the ballistic missile became the tool to reach the Earth's orbit and see beyond the horizon. From there, the threat of superior military technology forced the hands of some nations into a space race, putting man into orbit. Space is a hostile environment, and man had to learn how to move about it in safety, learn how to build machines that would function correctly. The race for dominance ended with man setting foot on the moon, our nearest celestial neighbor, then leaving it and forgetting that achievement for a time.
Tranquility Base here. The Eagle has landed.
Then came cooperation, nations learning to work together, almost forced into a partnership due to the simple fact of cost. Then a team spirit developed amongst other countries who began to explore near Earth and then further afield. We sent probes to other planets, taking photographs and measurements. Some have even left the solar system, carrying with them a message of peace from our small blue world. The Space Shuttle was built, the most complex machine devised by man, and with it we built a permanent space station orbiting Earth and manned by astronauts from many nations. We have sent tiny robots to the surface of other planets and rovers that could make their own way about, searching out and discovering things we did not know. Now we are planning for the next phase in our quest. Plans are now in action to return to the Moon and on then to Mars, sending new, smarter robots to move about where we cannot yet reach in search of life.
Our critical next step in all our space endeavors, and next for the new century, back to the moon, back to the future, and this time back to stay. And then a journey into tomorrow, a journey to another planet, a manned mission to Mars.
The Moon will eventually have permanent settlements, numerous bases and facilities for science and exploration to take place, but also tourism, which will be one of the major driving forces. Hotels and facilities for people to call the Moon home for a week or two. Lunar industry will blossom, with the need for the growing permanent and transitory populations, mining and processing of basic needs, air, food, water, building materials, fuel for further exploration. landing and launching facilities, space tracking and emergency facilities, hospitals and research centers, Earth observation points. Colonization of Mars can begin almost immediately, with the long-term goal of terraforming, allowing humans to eventually live and work out in the open. From there, heavy industry will take over, farming asteroids, looking for valuable minerals to manufacture air, water, and fuel. Next, a new generation of explorers will spread out to visit the moons of Jupiter and Saturn. Some will venture to Venus and Mercury. Perhaps permanent bases will be constructed on Titan, giant orbiting stations built from asteroid ores. Way stops for gigantic vessels journeying from Earth with paying customers coming to listen to the rings of Saturn. Here, scientists will find pockets of life under ice crusts or hidden in dark places. Faster spacecraft will take people out further, to Uranus and Neptune. Others will land and travel on orbiting comets and fleeting asteroids. All this will take time, money, and Herculean effort. Lives will be lost and mistakes made, but the advance is unstoppable. In fact, it is our destiny. There will come a time in the distant future when man must leave the planet Earth and even this solar system for good. As our sun grows old, its supply of hydrogen will dwindle, choking with helium and other heavier substances. At first it will fade. The sun will then change color and expand as its fusion fire finds other materials to burn, creating even heavier atoms, slowly eating itself away. Long before this eventuates, the Earth will be vaporized by the cool, expanding sun's surface. It will grow to the size of the orbit of Mars, then contract, darken, and cool. We humans, stewards of this planet, must collect all the life and biodiversity we can and move out to other stars and planets. For the materials in all the dying suns spread through our galaxy are what make up the DNA of ourselves and all other life. We are made of star stuff and must one day return home. In the millennia of times to come, we may look out and see we have spread out through the entire Milky Way and live among the millions of stars and planets we find habitable in the swirling galactic arms. Then we can look out, as Hubble has, and spy the billions of other galaxies that beckon to us from afar. The first Soviet and American pioneers had led the way in space flight. However, both nations realized quickly that they would require more manpower to achieve their goals. NASA selected a second intake of 9 astronauts in September 1962. They included Edward White, Elliot C. Jr., Frank Borman, and a young Neil Armstrong. The Soviets had formed the female core at this time and successfully launched Valentina Tereshkova into orbit. Perhaps this young American would have been the first woman into space. NASA training and selection staff who were vetting the Mercury 7 had also secretly begun vetting female applicants in another private facility. 24 applicants, all of whom were skilled pilots, were put through the same testing regime as the men. Jerry Cobb ranked in the top 2% of both male and female groups. 12 other women passed the stringent testing, but NASA wanted only test pilots, rejecting the female applicants. Jerry, who was a well-known pilot of her time, was offered an administrative position with NASA that lasted only 3 years. Cobb moved to South America and began humanitarian work, flying aid and medical supplies to indigenous peoples. She has since won many awards and accolades for her work, including the Amelia Earhart Medal. The Soviets picked another 15 cosmonauts for training, and NASA's Group 3 selection in October 1963 included Buzz Aldrin and Michael Collins. All but 4 of these Group 3 astronauts would survive training to fly Apollo missions. Theodore Cordy Freeman was not one. A test pilot and captain in the US Air Force, he had logged more than 2,400 flight hours in jet aircraft. Like all the other astronauts, Freeman flew the Talon T-38 jet aircraft as part of his training. On 31st October 1964, whilst flying the Talon, Freeman hit a goose. The bird smashed through his canopy, and debris was sucked into the aircraft's engine, causing a flameout. Freeman managed to eject from the jet, but was too close to the ground for his parachute to function. He was to become the first American astronaut to die whilst in training. Unknown at the time, however, was that the Soviet Union had also suffered the death of a cosmonaut in training. Valentin Bondarenko had perished in a simulator fire 3 years earlier. Like the Nedelin launchpad disaster, these were kept secret from the West for many years. Space travel would prove to be a harsh vocation. America's 2-man spacecraft, the Gemini, was ready. With it, a new launch booster, the Titan II missile. The Titan II ICBM had come into existence as the United States' primary intercontinental ballistic missile. It was a 2-stage rocket utilizing kerosene and dinitrogen tetroxide fuels. This allowed for the missile to be stored underground in a silo, fully fueled and able to be launched from that silo, unlike the previous Atlas. 31.4 meters tall and with a diameter of 3.05 meters, as a weapon it carried the Mark VI re-entry nose cone with a W-53 nuclear warhead, capable of a 9 megaton yield, the largest ever fielded by the United States. After modification and some refit, the Titan II was sent aloft with Gemini 1 on April 8, 1964. The unmanned Gemini was a test version only. Packed with instruments to study the new design, it did not even separate from the second stage booster. The mission lasted 3 orbits, although the craft remained in orbit for 4 days before it was deliberately destroyed on re-entry. Gemini 2 was also an unmanned test craft, this time to study the heat shield and re-entry of the Gemini design. Launched January 19, 1965, after a previous launch failure in December, the craft flew a suborbital flight across the Atlantic, reaching an altitude of 171.2 kilometers. Although it looked like an upscaled Mercury capsule, the Gemini was a very sophisticated flying machine. It had 3 major sections. The rearmost compartment contained oxygen tanks, pumps, communications equipment, propellant for attitude thrusters, drinking water, and a battery power supply. Later flights would house the new fuel cell device to generate electricity from oxygen and hydrogen. Prior to deorbit, this section is jettisoned, exposing the midsection with the retro thrusters. These would slow the craft and drop it from orbit. The section is then jettisoned to expose the heat shield on the main craft. The Gemini was designed and developed by Canadian Jim Chamberlain, an aircraft engineer. The spacecraft was capable of making major changes to its orbit and altitude. It had a complete maneuvering system with onboard computer control. It was also designed to dock with an Agena docking target. It incorporated 2 hatches, 1 for each astronaut. The design also incorporated ejection seats. In case of a launch abort, the astronauts would eject individually and parachute down. One other innovation which was tested but eventually dropped was the paraglider. Designed to allow for a controlled descent, the glider would deploy after re-entry and the pilot would glide the craft to a ground landing. In the end, a standard parachute and water recovery was used. With the Soviets quietly developing their next generation of spacecraft, Gemini was ready to take center stage. It was time for America to put a man back into space. The tradition of astronauts naming their spacecraft was being discouraged by NASA, but Gus Grissom insisted on naming his next spacecraft. Having lost his first one, called the Liberty Bell, to the ocean depths, Grissom named his Gemini Molly Brown. It was taken from a Broadway musical of the time, The Unsinkable Molly Brown. NASA were hesitant. His second choice of the Titanic clinched the deal. Prime crew of Gemini 3 Grissom and second intake astronaut John Young lifted off aboard Molly Brown on March 23, 1965.
3, 2, 1, 0. Bolts and liftoff. Master clock has started.
Scheduled for 3 orbits, the series of engineering experiments included extensive maneuvering of the spacecraft, including changing the orbit and inclination. One other experiment involved a corned beef sandwich belonging to Young. Grissom was scheduled to eat specially prepared NASA space food. Unimpressed with the menu, Grissom pinched the sandwich and proceeded to eat it. The spacecraft returned to Earth 60 miles short of their intended splashdown, but they were recovered within 2 hours by the aircraft carrier Intrepid. Soon after, on March the 24th, the last of the Ranger probes descended to a hard landing on the lunar surface. One increment at a time, NASA was testing each and every technical challenge to reaching their goal. They had selected several potential landing sites for an Apollo mission. Now they had to see if a soft landing was possible. The next series of probes, Surveyor, would attempt to touch down under power on the lunar surface. June 3, 1965. Edward White and Jim McDivitt rocket aloft aboard Gemini 4. Their goal? To finally catch up to the Soviets and their daring spacewalk. Once in orbit, Ed White opened his hatch and stood up outside the craft. Then, attached with an umbilical cord, he maneuvered clear of the ship. White tested a small handheld maneuvering unit and broke Leonov's record by 11 minutes. Gemini 4 completed 62 orbits. This moment, caught in full color, is arguably the point where the United States finally eclipsed the Soviet manned program and, with the rest of the Gemini project, began to pull ahead. Gordo Cooper and Charles Pete Conrad were next with Gemini 5. On board, a new device, the fuel cell designed to supply electricity by mixing oxygen and hydrogen, prolonging mission times beyond what batteries could supply. Their mission was also scheduled for 8 days and a new flight record of 120 revolutions. They did experience trouble with the fuel cell, which was shut down and reactivated, permitting the long stay in space and proving the human body could survive the time it would take to reach the moon and return.
Successfully launched with a redesigned new shroud.
The Mariner 4 spacecraft flew by Mars in July 1965. It provided the first close-up photographs of the Martian surface. It revealed that the surface was pockmarked with meteor impacts similar to the lunar surface. 22 photos were taken and recorded on magnetic tape. It took around 9 days to transmit the photo data back to Earth.
Very little water present since that time.
Launched November 1965, the Soviet Venera 3 probe successfully reached Venus in February 1966. It impacted the Venusian surface and became the first man-made object to reach the surface of another planet. Unfortunately, prior to descent, the probe failed. No data was returned. The next scheduled launch was Gemini 6. Her mission? To dock with an Agena target in orbit, to study how a lunar mission would link up spacecraft. But the Agena launch failed. With a quick reschedule, Gemini 6 was postponed, and Gemini 7 was launched on December the 4th. It was going for another duration record, this time 2 weeks or 206 rotations. Gemini 6 attempted another launch. The main engine shut down on the pad without any damage.
No liftoff. Verify program reset.
A second attempt was made 3 days later, 11 days since Gemini 7 was launched. This time she made it to orbit. With some elaborate flying by Wally Schirra and the onboard computer, the two spacecraft enacted a complex rendezvous and station keeping in orbit. Aboard Gemini 7 were Frank Borman and Jim Lovell. Aboard Gemini 6, Wally Schirra and Tom Stafford. 4 astronauts in space at the same time, a new space record. Gemini 6 completed 16 orbits, then returned to Earth. Gemini 7 remained in orbit a further 3 days. As advised, the astronauts had brought along books to read. Gemini 7 would go on to hold the space flight endurance record for a further 5 years. The Soviets were not idle. Lunik 9, also known as Luna 9, was launched early February. After achieving orbit aboard an R-7 booster, a 4th stage then fired its motors and put the probe on a translunar trajectory. This was their 12th attempt at a soft landing on the Moon. Luna 9 soft landed on the Moon February 3 in the ocean Procellarum, the Sea of Storms. Another first for the Soviets, it also proved that a man-made object would not sink into the lunar surface as some had suspected. Elliot C. was backup crew along with Neil Armstrong on Gemini 5. The way astronaut crews were rotated meant that they would be prime crew on Gemini 8. However, C. was promoted and became prime crew on Gemini 9 along with Charles Bassett. C. was piloting a T-38 trainer with Bassett on board, attempting to land at Lambert Field, St. Louis in poor conditions. C. was coming in too low and struck the very building where their spacecraft was being built. Both were killed instantly. The accident was a great loss to the astronaut community. However, as trained for, the backup crew stepped up to become prime crew. This altered the roster of astronauts' schedule and in effect put Buzz Aldrin in a seat next to Neil Armstrong. Still yet to achieve a hard dock in space, Gemini 8 was sent aloft on 16th March. Commanded by the first civilian astronaut, Neil Armstrong, the launch went as planned, as to the Agena target rocket less than 2 hours earlier. The Agena worked properly this time, placing itself in a circular orbit some 300 kilometers high and orientated itself for a docking maneuver. Gemini made several burns to modify her orbit and bring her within 330 kilometers of the Agena, where they made radar contact and closed in. At 104 kilometers, they made visual contact and placed the computer on automatic. They closed in and inspected the Agena for any damage. Then Armstrong took the Gemini in and made a hard docking with the Agena. Next, Scott was to make an EVA to the Agena, but events quickly turned a success into an emergency. The two connected craft began to spin. Armstrong made corrections, but the spin returned. Ground control suspected the Agena at fault and ordered it shut down. The spin continued out of control. Armstrong radioed to Houston that they had a serious problem. Gemini's fuel was dropping as well. They made the decision to undock, but once detached, it was found the Gemini was at fault and continued to spin out of control. Unknown at the time was that a maneuvering thruster had jammed open and was consuming their fuel at an alarming rate. The spin increased to 1 revolution per second. Only moments before the crew would have blacked out, Armstrong took manual control and made an emergency decision. He shut down the automatic thruster system and engaged the RCS, or Re-Entry Control System, to bring the violent spinning under control. Mission rules dictated that if the RCS was used for any reason, the flight must be aborted. Gemini 8 made an emergency landing with 2 very lucky astronauts. Three months later, the Surveyor spacecraft made its first attempt to make a soft landing on the Moon. June 2nd, 1966, and less than 15 kilometers from its target in the southwest portion of the Oceanus Procellarum, Surveyor 1 touched down exactly to plan. The craft returned television images and scientific data on the radar reflectivity of the lunar surface. It also vindicated the engineering concepts utilized for a soft landing that the manned Lunar Excursion Module would later rely upon. 2 months later, in August, Lunar Orbiter 1 set off for the Moon. It suffered several problems en route, but these were resolved by the time it reached lunar orbit. Her mission? To take high-resolution photos of lunar terrain for soft landings of both Surveyor and later Apollo missions. She photographed over 5 million square kilometers of the lunar surface. She was also directed to take 2 photographs of Earth, the first time man had seen the Earth from that distance. With its new crew of Thomas Stafford and Eugene Cernan, Gemini 9A was troubled from the beginning. Their Agena target booster failed to reach orbit. A second booster was prepared with only the ATDA, or docking section, of their Agena target fitted. It lifted off from Cape Kennedy June 1st. Gemini 9A was to follow the same day. But during launch, communications with the onboard computer failed and the launch was aborted. They had to wait 2 days for another launch opportunity, and on June 3rd, successfully made it into space. Once in orbit and maneuvering to their target, Gemini 9A discovered the launch nose cone of the docking unit had not separated as planned, and they watched an angry alligator, as they called it, close in on them. That part of the mission was aborted. Next, Cernan was to EVA and test a new maneuvering backpack unit housed at the rear of the Gemini. His spacewalk was doomed from the start. His visor fogged up, his air-cooled spacesuit overheated with the exertion, not enough thought had been put into exterior handholds and the difficulty of moving about in free fall. Cernan had to abort the exercise and return to his seat. Even then, they had trouble resealing the hatch. Later spacesuits would be liquid-cooled, and a more realistic EVA schedule plotted. Gemini 9A made 47 orbits, then returned to Earth. In comparison, Gemini 10 worked like a charm. Their Agena booster functioned flawlessly. Michael Collins and John Young docked with the craft after giving a fuel-consuming chase in low orbit. They then fired the Agena rocket motor and ascended to an orbit of 763 kilometers, the highest a human had ever traveled, and they achieved this whilst flying backwards, or eyeballs out as they called it, and not particularly comfortable. There they circularized their orbit and slept for 8 hours. Their first EVA was simply to open the hatch and stand up in their seats and take photographs. Their onboard experiment studied radiation levels at that altitude, along with radiation flux and energy flux detectors. Once they undocked from their Agena booster, Gemini 10 maneuvered away and went in search of Gemini 8's Agena target. They found it and closed into a 3-meter rendezvous with the booster. In all, Gemini 10 made 43 orbits of the Earth and splashed down only 5 kilometers from target. With only 2 more Gemini flights scheduled, the program was coming to a close and the next phase about to begin. With work on the 3-man Apollo spacecraft and lunar lander proceeding well, tests on the new booster, the Saturn 1B and the mighty Saturn V, were proceeding. The hardware to put a man on the Moon was coming off the drawing board and into reality in both camps. The Soviets' chief engineer, Korolyov, was about to unveil his masterpieces, the Soyuz spacecraft and his moon rocket, the enormous N-1.
3,